स्टार्ट होगी। आप यूट्यूब का लिंक कॉपी करके फिर आप डिस्कस कर लें मुझसे। माइक म्यूट है आपका।
मैंने लिंक कॉपी कर लिया है, मैं उनको भेजने लगी हूँ। और दूसरा ये है कि ये लोग खुद आ रहे हैं, हम इनको नहीं कर रहे एडमिट। ये क्यों हो रहा है ऐसे?
सारे वेटिंग रूम में ही हैं, सिर्फ 3
नहीं, अभी
पार्टिसिपेंट्स हैं मीटिंग में।
अभी किए हैं कुछ लोग दोबारा वेटिंग रूम में।
चलें, वो मीटिंग रूम मैंने अब अवेलेबल किया, पहले नहीं था।
अच्छा, अब जो हम एडमिट करेंगे बस वही लोग आएंगे।
जी जी।
अच्छा, बहरहाल आपने रहना है पहले हमारे साथ ना, ये अभी कुछ देर।
चलो मैं आपको होस्ट भी बना रहा हूँ, ठीक है।
लेकिन आपने
अभी
एज ए
को
को होस्ट रहना है, क्योंकि
ठीक है
अभी मैंने।
ठीक है।
हाँ
ओके।
जी। मैं तो एकदम कंफ्यूज ही हो जाऊँ ना, क्योंकि चीजें मैनेज करनी होती है। अस्मा, आसिया किधर है बेटा? आप लोगों ने यही
मैम
करना
मैंने
है।
उसे टेक्स्ट कर दिया था, वो कह रही है आ रही है, ज्वाइन कर रही है।
अब आप लोगों ने यही करना है बेटा, आप लोगों के जिम्मे है सारा। अब ये सारे लोगों को आपने एडमिट करना है जो भी आ रहे हैं, और कुछ
ओके
मैं आपको चीज भेज देती हूँ, उन लोगों को आपने पहले एडमिट कर लेना ना।
जी मैम।
और साथ साथ मैसेजेस आपने ये करने हैं, वो मेरी जो ईमेल आईडी है ना, वो आपने
जी
अनाउंस करनी है कि जो लोग जो है वो, चलो वो मैं फिर कर दूंगी, जो वो होंगे पहले भी कर देना कि जो लोग इन हो गए हैं वो अपनी जो नेम है और अपना डिपार्टमेंट का नेम है, वो हम इस ईमेल पे, मेरे ईमेल एड्रेस पे ना मैसेज कर दें,
ओके
ईमेल
मैम।
कर दें, ठीक है। उससे ये होगा कि हम फिर उनके सर्टिफिकेट जारी कर सकेंगे ना, जो जो लोग होंगे, हमें नहीं पता कौन कौन ज्वाइन कर रहा है।
ओके मैम।
अच्छा, ये अब की सारी डिस्कशन जो है हमारी ऑन एयर है, तो आप मुझे
ओके।
को होस्ट भी बना दें।
अच्छा
मैंने आपको
अच्छा,
होस्ट
ठीक
बना
है।
दिया।
अब मैं आपको होस्ट बना देती हूँ।
मैम
जी जी जी।
मैम आसिया और कनेक्ट करने की कोशिश करिए, उससे लेटिन करने।
चलो जी। हम्म।
मैम मैंने कर दिया एडमिट।
Starting with the name of Allah, the most merciful, the beneficent. And good morning to all of you. A very warm welcome to all participants, and I'm extending my welcome to the prestigious and respected faculty members and the all speakers who joined us. And before we start it formally, I would like to ask Miss Asya, who is our student in Department of Mathematics, the Women University Multan, to please recite some verses of Holy Quran. And here is Miss Asya Asghar.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد آمنت بالله صدق الله العظيم.
ठीक है. Jazakallah, and thank you so much, Miss. She was Miss Asya Asghar, and as you know that the meeting is started, and the participants are joining us, and I feel that we should wait for another 2 or 3 minutes, such that all the participants may join us to start it formally. Welcome to all the participants who are joining us, and we are reaching to all the participants, and I'm joining them. And all those who just join us, welcome from me and from Department of Mathematics. And I can see that there are so many colleagues and my students and the other faculty members who just join us. So again, a very warm welcome and a good morning to everybody who just joined us. And on the behalf of Mathematics Department, I am Jile Shams, lecturer in the Department of Mathematics, the Women University Multan, and I am extended my warm welcome and my warm greetings to all of you on this one-day international webinar on the challenges, opportunities, and the innovations in mathematics. And I would like to pay my thanks to all the faculty members who just joined us and all the speakers who just joined us. I want to put some light on the Women University Multan. The Women University Multan has the distinction of becoming the first university of women in the city of Multan. And the Women University Multan is playing a vital role in educating women, especially in the South Punjab, Multan, and South Punjab and Multan in Pakistan.
मैम आपकी आवाज नहीं आ रही.
So the university mission to highlight the importance of education, which can serve as a gear to empower women, makes this newly established university into a hub of knowledge. Mathematics department is developing day by day, and we are 7 permanent faculty members, in which 3 are assistant professors, and there are visiting faculty members. We are having 15 visiting faculty members, and who are working with us very hard to make this department an ideal place to learn mathematics. We are much focused to enrich our students with the deep understanding of mathematics to apply into the real life. And that's why we are gathered here to discuss about the challenges, innovations, and opportunities in mathematics, to highlight the need of mathematics in future world. And we are today blessed with so many people here, so many great mathematicians, and so many people who are serving their life for the mathematics. And again, I am welcome you all. I am going to welcome you all for your precious lives, your precious time that you are spending for the mathematics. And this is actually a great love for this field. And I appreciate your this devotion to mathematics. And now I am again saying that we are blessed with the great mathematicians today, and who are the experts of the application of mathematics in the real life. And they are real mathematicians, and they join us from all over the world, and the speakers from the prestigious top ranked universities from all around the world. And we are having today Dr. Aisha Asloob Qureshi, who is the assistant professor in Nasi University, Turkey, and also Dr. Fiza Zafar, who joined us. She is an associate professor in Bahauddin Zikriya University for the Center of Advanced Studies in Pure and Applied Mathematics. She is also having the position, she is focal person of women in STEM at the BZU Multan. We also blessed to have Dr. Stephanie Bauta. She's associate member of the group of astronomy and the dynamical system, visiting scientist at many prestigious institutes in the world, and she is having connection and collaboration with so many institutes in the world. And also she is the adjoint director of international relations, and she is working as the associate professor in the University of Federal de Rio de Janeiro, Brazil. Also we are having Dr. Fatma Athral. She is the member of the directory board of the Brazilian Organization for Women in Science for the Developing World, adjunct professor at the Federal University of Rio de Janeiro and Brazil. Also, we are blessed today to have Dr. Kamran Sumro, who is a proud for Pakistan, and he is a senior lecturer from University of the West of England, Bristol, United Kingdom. And while I can see that our speakers also join us, and there is, I can see that the head of department, Women University Multan, head of Department of Mathematics, the Women University Multan, Multan. Dr. Kamar Bab just joined us, and I can see that the Dr. Aisha Asloop just joined us, and I can see the Dr. Fiza Zafar and Dr. Hadi Shikharis from the Iran just joined us. And I want to extend my welcome to all those participants who just joined us, and my warm greetings for all those who are spending their precious time with us, and they are going to highlight the mathematics and the need of mathematics today. And for the new participants, I just want to highlight that the Women University Multan has distinction of becoming the first university for women in the city of Multan, and it is playing a very important and vital role in this region in the South Punjab, Pakistan. And we are doing our best to provide the students real learning of mathematics, to apply this mathematics in their real field. And the Women University Multan is becoming the hub of knowledge, because we are going to emphasize, we are going to empower the women, and this empowerment make this newly established university into the hub of knowledge. And I'm very excited to pay my gratitude to all the participants. And I'm again going to introduce Dr. Aisha Sloop Qureshi, and please, ma'am, accept my welcome. And she is the assistant professor at the Nancy University, Turkey. Okay, and we are also blessed today with Dr. Kamran Sumro, who is the senior lecturer from the University of West of England, Bristol, United Kingdom. Today, Dr. Muhammad Hadi Shikharis, who is also the participant now, will join us in this one-day international webinar related to the challenges, innovation, and opportunities in mathematics. And he is the assistant professor at Shiraz University, Iran. And we are also blessed today with the Miss Wajiha Rahman, and she is the real model for us for the hard work, and for the she's the girl who follow her dream, and she did the dual masters she was an engineering student, and then she adopted mathematics as her career in the life. And she did dual degrees. One degree she got from the France, and one is from the Belgium, and now she is the Marie Curie, having the Marie Curie fellowship, and she is now the postgraduate student in the Leeds University, United Kingdom. And today we are also blessed to have Miss Fatma Athral. She is the doctor, and she is working in the neurosciences, and she will talk today on the women in sciences, and she will tell us that how the mathematics is important in the neuroscience even. And likewise, we are blessed today with one of the minister in Pakistan, and he is working for the social welfare, and he is the minister for Baitul Mal. And let me see that if the women vice chancellor of the Women University Multan join us. Please give me a 1 minute.
ताज़े खरबूजे आ गए, ताज़े तरबूजे आ गए, ताज़े खरबूजे आ गए, ताज़े तरबूजे आ गए, ताज़े सेब आ गए, ताज़े आलू आ गए, ताज़े लोग आ गए।
I also want to welcome Miss Mariam Nazar, who she just joined us and she is from the Azad Kashmir, and she will give us her little introduction here. And she is working with the mathematics from long time. And here is Miss Maryam Nazar.
Assalamu alaikum. Welcome to all of you to this one-day seminar. I'm Maryam Nazim from Mirpur University of Science and Technology, Must. And actually my field of research is the geometric function theory of complex variables. And it has a vast impact and research area, and its application in all fields of life, including the physical, mathematics, and all other sciences like fluid mechanics, etc. So actually, I'm going to tell you that I have done my MPhil from the Mirpur University of Science and Technology, and now I am the PhD scholar here. Also, I am serving here as a lecturer for more than 11 years, and I have 9 publications in my research area. I want to tell you a little bit about my research. So actually, this is the field where the work is not done too much, and it is the field, the study of geometric properties of analytic function, and it is the branch of complex variable. And first of all, I will give the first hearing to the geometric function theory in 18th century, and the modern theory was developed in 19th century. So this is not as much old as the other field of science. So we are doing work in this, and recently we are working on the geometric properties of analytic function along with the Q differential operators, along with the method of solving differential equation in complex variables. So I'm not going in detail because I don't know how much time I have given from the Zileshans. So I just give you a little bit introduction about the applications of my field. Where can we use this field in our daily life? So geometric function theory is a classical subject. It has several connections with the mathematical physics and engineering and the electronics and the fluid mechanics, and the conformal mapping is mostly applied in solving eigenvalue problems in plane, and this method is known as conformal transplantation. And the theory of compact demand surfaces has extensive usage in the providing finite gap solution to a non-linear integrable system. Also, to compute the uniform potential around an ensemble of the circular obstacle is also is a core and the fundamental issue in the fluid mechanics. And we can solve all the prototypical examples of the physical problem involving the multiply connected domain in the field of this geometric function theory of complex variables. Also, we make use of the differential subordination to solve the differential equations in the complex variable and transform, and there is no order relation in the complex. So to overcome that difficulty, what we do, we make use of the concept of subordination. So it is not too old as the other fields of sciences, but there is a lost and vast research in this geometric function theory of complex variables going on. So I'm a lecturer here at the, I'm here presenting the Azad Jammu and Kashmir, and it is a state, Mirpur Azad Kashmir, the state of the independent Azad Jammu and Kashmir, and here I'm lecturer at the Mirpur University of Science and Technology. And here I just give you a little and brief introduction of my research area and what we are doing to give our research area and our geometric function theory of complex variable, how can we involve it in the theory in modern sciences. So,
thank you so much. And she was Maryam Nazir, who just Mariam Nazir, sorry.
Thank you so much.
She is Mariam Nazir, and she is from Azad, Jammu and Kashmir. And as you know that our purpose of the today's webinar is to highlight the mathematics and as well as to highlight the mathematicians from different areas all around the world. And we are very blessed that the Madam VC, uh, the Women University Multan, just joined us, and we are very blessed to have her here. And Madam, please accept my welcome, and I am very thankful for that. We can understand your busy schedule, and but before we go to start, let me tell you that we are today blessed with so many good mathematicians from all around the world. And we are having Dr. Aisha Asloop Qureshi. She is from Turkey. She just joined us. And the Dr. Fiza Zafar. Dr. Fiza Zafar, she is the associate professor in Bahauddin Zikri University for the Center of Advanced Studies in Pure and Applied Mathematics. And she is also the focal person for STEM in women in Bahauddin Zikri University for women. And there is Dr. Kamran Sumro, who will join us as a speaker, and he is the data scientist at the National Health Society, or the National Health System. And he is also an assistant professor at the University of West England, Bristol. And likewise, we are today blessed to have Dr. Hadi Shikharis, and who is the assistant professor, and who is from Iran. And there is Dr. Fatma Arthal, who is from Brazil, and she is working for the developing countries, and she is especially working for the mathematics. And likewise, today we are blessed to have Dr. Stefnila Bauta, and she is a very famous mathematician, and she is collaborating with so many institutes all around the world. And she is also an associate professor and adjoint director for the international relations, and she is doing very great in mathematics. And also there are some more speakers from the University of Leeds, United Kingdom, and there is Dr. Fatima Saharzadi. She did her PhD from France, and she is doing her postdoctorate. And also we are blessed to have Dr. Uzma Qureshi, the Vice Chancellor of Women University Multan, and she is one of the role model for us and a real source of encouragement and motivation. And she is a golden-hearted lady who just support us, and her support is always continuous and unconditional. And let me say you that no doubt without her vision and unconditional support to us, it was not possible to make this happen. And she always support us in all these, and she always encouraged us to do these type of the things, to do for our students, for our university. And that's why we are here gathered to make this happen. And we are here for the one-day international webinar on the challenges, opportunities, and innovations in mathematics. And I welcome you, madam, and this is your time.
Right. Thank you very much, madam, for this very nice introduction. Of course, without good team, nobody can succeed. And this goes without saying that my team is the one which I'm very proud of, and always can rely on them for good performance. And Madam Shams, Zille Shams, you are one of our best faculty members, and I had all the faith that you will be doing a very excellent effort to bring together all the mathematicians from different parts of the world to think through and to talk about research areas, and also share their experiences so that we can learn from one another and bring to the fore the issues that are most important in mathematics education and mathematics research. Madam, I would also take this opportunity to thank your head of the department, Dr. Kamarubab, who is also present and always praises her team. You know, also is very pertinent to mention here that without good leadership, people can't really, any department cannot flourish. So in her efforts to improve mathematics education and also help faculty members achieve goals is very, very important, and she has been doing a very good job. Madam Zille Shams, since I've joined this university, I have always admired your enthusiasm, your hard work, and your commitment to the betterment of mathematics education at WUM, but not just here, but also improve mathematics research in mathematics, which is something we are going to focus on quite a lot. And we are also thinking of starting an ADP in mathematics so that we can prepare human resource which can then go in their choice and perform their duties to the best of their ability, and we want to increase their capacity so that wherever they go, they become an asset and also do their job, with with the required level of competence. Once again, I congratulate the Department of Mathematics and Dr. Zille Shams for her efforts to bring so many people together. I'm looking forward to the webinar. Welcome to all the participants and looking forward to attend it. Thank you so much, madam. Madam, unmute your mic kindly.
Thank you so much. And thank you so much. And she was Dr. Uzma Qureshi, and she is the Vice Chancellor at the Women University Multan. And thank you so much ma'am, for your precious and kind words for us. And definitely these words and this encouragement matters us to all very much, and this is your support and the positive energy that you provide us and make us to do hard work in this university. And I am again saying thank you to the all participants who just joined us and all the speakers who are joining us and giving us their precious time. And today we all are blessed to have Mr. Jawar Abbas Bukhari, who is the chief guest here today for the one-day international webinar on the opportunities, challenges, opportunities, and innovations in mathematics. And I would like to welcome him, and let me see if he joined. Please give me a minute. Sorry to all the participants that I have to see that if the chief guest join us.
What do you want me to speak about?
And I'm going to welcome Mr. Jawar Abbas Bukhari, who is a renowned politician in Punjab and a sitting minister, Baitul Mal and Social Welfare of Punjab. And he is also serving as the chairman of Public Account Committee, and he is supportive to the Educational Institute, especially the Education for Women. Sir, I welcome you on the behalf of Women University Multan, and today we are blessed with you and as well as the Vice Chancellor of the Women University Multan. And today we are having so many mathematicians from all around the world, and we are blessed to have the speakers from many universities, international top ranked universities, and they just give their precious time to us, and we please accept my welcome and thanks for your precious time, and sir, this is your time. Sir, your mic is mute.
Thank you very much for your time. The Women University Multan is immensely obliged for your time and your guidance. You need to unmute your mic before you speak, sir.
Okay, I think I'm okay now. Thank you very much, Zile, and I'm honored that you people invited me here. And one of the best things is that it's on a subject that I used to be very bad at, and it's one of those subjects which is the mother of all subjects, if we really look at it, because everything is derived from it, be it algebra, be it statistics, be it physics, and be it chemistry as well. And believe me, when I was applying for medical school in the UK, mathematics was one subject that was a must at that time. And that's when it hit me and I understood the importance of mathematics. With experience, then you learn what your own mathematicians or your scholars in the Islamic world had done many centuries before us. And recently, we are about to renovate the laboratory of Al-Biruni in Chakwal area, in Jhelum or Chakwal area, where he measured the circumference of the earth. So this was all done by our people who put in a lot of effort. And since then and today, where have we gone wrong? We used to have a lot of scholars then. What went wrong after that?
Thank you, sir, for your precious words. We are very much grateful.
I just went off, I think, for a second. What I wanted to say was that mathematics is one of those subjects, or the one subject, where we need to start from a very, very early level. And by the time our students have gone up to the 10th grade, we should be able to make models and write formulas down to derive things like what kind of an effect a disease would have on a population and stuff like that. We as a nation are very shy from maths. Whereas if you travel further east from us, India and further east, they're good at maths. We have some brilliant students in maths. My own son has done his bachelor's in pure maths, which is very surprising. But we need more mathematicians because our industry, our country is an evolving country. It's a developing country where research and development, although was never emphasized as much, but now with passing times and the kind of problems we are facing in the world and the cost of technologies that we import, we need to have our in-house research and development. And for that, we need to have more people whose pure maths base is very strong. And they've then gone on to engineering, physics, wherever, be them becoming statisticians or people who sit and work out what effect different things will have on our population. So statistics, be it anything else, algebra, these are important things where maths is the pure base and we need to build that up.
Thank you, sir. Thank you very much for your very important thoughts on the subject and why it is so important for a country like Pakistan to focus on mathematics education, and that is the very reason why we are holding this webinar. We believe that somewhere along the line in our education system, we diverted from the real focus of why do we educate people. We empower them as citizens of a country and help them develop skills which would then help them further to locate themselves in their chosen fields. Mathematics, as you said, that we were not able to score very well. A lot of people claim that. But I think the primary reason is that there's so much fear which has been created around this subject. I think every human being has the potential if it is unleashed properly. And that is why our mathematics education is a flagship program at the university. We are also focusing on languages. We believe that international languages, along with our national language and mathematics, understanding of mathematics, is the core knowledge skill which we need to help our students develop important understandings, disposition, and empower them basically as learners and performers in their fields. So thank you very much, sir, to sort of reassure us that we are on the right track.
Professor Seba,
And
there's
we
just
also
one little
Yes,
thing
please.
that I would like to add on to what you're saying, and what you're saying is music to my ears, which is thanks God that you've understood the problem, that our emphasis have changed, and this has happened over the last 45 years. If you look at it, that we, from being a knowledge society to some extent, we have gone towards a materialistic society. And what that has done is get a degree. Does not matter what degree you are aiming at. And the kind of degree that you go for is you getting a job as soon as you have done your bachelor's. It doesn't matter anymore that what degree do you have. As long as you have a powerful politician backing you up or a powerful bureaucrat backing you up, you will get a job. And this needs to be changed because uh, our people who have been working abroad, most of the boys who have done their PhD in maths or PhD in various science subjects, they end up working abroad. That's because we are losing our talent. We're losing the brain that is supposed to be doing everything in Pakistan, and we are stuck now. What needs to be done is that students, because you are in the university, you people are guiding people, you people are setting up the different courses that your students follow. But if we are given these particular students from a very early level, if they are given the right content, as they say, and the context about the subject, the information, and why maths need to be, emphasis need to be laid on maths. If I've heard and I've read a bit about Israel, what they've done is, what Israel has done is that the mothers, the females, married females, when they get pregnant, and as soon as they find out, they start solving mathematical problems so that the baby in the womb, genetically or the vibe through the energy from the mothers, and this is what our religion tells us as well. That's why if you see most of the ladies nowadays who have known about this, even my own daughters, they would start the recitation of the Quran loudly so that the baby hears the recitation of the Quran in their wombs. This is what needs to be done with maths, because Quran is the epitome of mathematics. If you look at it, the way it has been laid, the way now research tells us what the Quran is, it's pure maths. We need to understand that, and we need to emphasize that with our children, and not just our children in regular schools, our children in the madrasas as well. Because if our ulema tomorrow are good at maths, the mindset changes. If their mindset changes, the majority of the population, when they hear them on a Friday delivering their sermon, or during a majalis, or during any milad, mindset changes. We need to change the mindset. And it's going to not take us 5 years, it's going to take us 20 years. Let it take 20 years. 20 years in the age of a nation is nothing. But we need to be, it's us lot who need to be persistent. And it does not matter if we face setbacks, those setbacks will make us better people, better educators. So let's look at that. Let's not look at the pitfalls. Let's look at if we get successful, what that success will bring for the country.
Absolutely, sir. I couldn't agree with you more. And I think this is what the essence of this whole education is all about. That knowledge is mistaken for just having information about a subject. We need to look at when you have information, how do you synthesize it and what is its application in real life. And this is what we are also focusing on. You'll be glad to know that we have social action programs which are now reaching out to disadvantaged communities to help them with education. And we have proper early education program initiated by our Department of Education to help them in science and language and mathematics. And that is a real focus, and keep it very real life mathematics, we call it. We don't just familiarize students with numbers, we familiarize them with life, how these numbers are applicable to our life. Just as you've said, that Quran is a mathematical miracle. If you look at how it has been written, how it has been organized, how it is being visualized by the Almighty Allah Subhanahu wa Taala to all the knowledge bearers of our religion use mathematics to resolve many problems which were faced by the society at that time. Now we need to go to the basics, understand that mathematics is not a subject, it's a way of life. And you need to understand how you can use your mind more scientifically and more appropriately to resolve the issues that surround you. So we are very, very grateful for your presence, and your patronage would be really helpful because we have students from very disadvantaged area of the region who come with a lot of hope to this institution, and your patronage would be a great strength for all of us. Thank you again for your time and your very thoughtful remarks, which would be a guidance to all of us in future. Thank you. Over to Dr. Zilani.
Thank you so much, Sir Jawar Abbas Bukhari, and who is renowned politician in Punjab and sitting Minister Baitul Mal and Social Welfare of Punjab, Pakistan. He is also serving as chairman of Public Account Committee. Thank you so much for your precious words, sir. And these words are really matter to us. And thank you for your kind words and your precious time. And we are very blessed to have you in this seminar. And I also want to extend my thanks to Madam VC, Dr. Uzma Qureshi. She is the role model for us, a real source of encouragement and motivation. And actually, she did a lot for our university, and and her unconditional support to make this happen. And now I am going formally to start this session, to start this one-day webinar on the challenges, opportunities, and innovations in mathematics. And I feel that this is a very vast topic and cannot be complete or cannot be discussed within one day, but this is over little effort. And
Zile, if I may interfere.
Yes, sir.
If I may interfere for a second here, because I've got meetings after this. What I would like is that whatever the end result you people arrive at after this webinar, please keep me in touch so that we can come up with something that kickstarts the education of maths from the very early level. And it should be something where by the time our students have passed, for example, their metric or O levels, they should be able to sit together and should be able to use mathematics as a tool. And that's where practical, it's laboratories and practicals for not just essential for biology, maths, and chemistry and other subjects like that. We need to come up with practical models for maths, and we want to make maths interesting, where people fall in love with maths, with numbers. Like we got scared. My son loved it. So it's one generation to the other, the mindset change, but we need to change it across the spectrum where our children genuinely love maths. We need to come up with practical models and practical way of making young students at that very young age fall in love with maths. And that should be our
Practical
criteria.
steps. Absolutely. Couldn't agree with you more, sir. Just having a webinar or seminar or sitting together would not help unless we come out with some concrete steps to take, not just in higher education, but in early education also. In fact,
Ma'am,
I will take this opportunity. Yes, sir.
Ma'am, where I would like
Yes,
to, I keep butting in because I've got another meetings and I need to be there as well.
I can see the
But this is
passion,
far
see.
too important a subject. This is far too important a subject where if I have my hopes and my dreams about the future Pakistan, it should be based on science. For science, you need maths. For maths, you need good tutors. To have good tutors, you need to have good skill development, mathematical skill development. It should be psychosocial because you need to deal with the mindset of the students where you make them fall in love with mathematics. And then mathematics is something which is the mother of all subjects. Everything else is derived from maths. So like we have institutes of software technology, we could have institute of mathematics.
Yes.
If people who are purely mathematical minded,
And Center
like
of
in
Excellence
America,
for
what they do,
Mathematics. Absolutely.
they look at
Mathematics,
students
education and
who
research.
have special powers like telepathy, and they take them to special schools and focus and sharpen their powers. Like that, we need to do with maths. Once we have these people, the area I come from, we have the Pakistan Aeronautical Complex all around my village where I live. And over there, they're developing the 5th generation fighter. For that, you need mathematical models. Then they're developing an aircraft which will be suitable to be flown as in PIA, a transport plane, things like that. And that's where you need not just physics or algebra or be it anything else. The root is maths. So if the normal government think tank or mindset does not allow us advanced or better teachers teaching maths, we could always look at Institute of Pure Maths. With children from day one, they are taught other subjects as well, but more emphasis on mathematics. And that's where we will get, even if you say 500 students coming out of that institute all over Pakistan per year, you have 500 people who might be amazing at maths. They could be your master trainers tomorrow.
Yes, we'll definitely work on along these lines. Center for Excellence for Mathematics Education and Research would be our next venture, inshallah. We are working on that. I'll take this opportunity to inform you that I've been also appointed chairperson of the Punjab Examination Commission. And there I am directly dealing with this examination and mathematics, how it is being taught in early years. And I have asked them, extended our support to them as a university to sort of assess at every step of the way, to understand where are we going wrong and how we can straighten it up and have integrated approach to teaching and learning, not just confined to a subject, but how these are linked and then make a stronger base for the students all over Punjab. The Women University Multan will be playing a very significant role, and we'll keep you posted. We'll share our ideas with you, and we would then request you to extend support because you do so have access to the corridors of power and people who make the final decisions for education in this country. You would be a voice for this university and many students who benefit from the research which will be conducted here with the Punjab Examination Commission as well. Thank you, sir, once again. For
I'm
Thank you
honored
so
and
much.
grateful, but I would like to take this further, that we should form a group of people who are influential within the government and within the bureaucracy. And that should be like a think tank, which should then look at and work towards what we are talking about.
Thank you so much. Thank you so much. And we witnessed a beautiful talk between two precious minds. And we are very blessed that you are thinking for the mathematicians and you are thinking for mathematics. And really, it is a really happy moment for all of us, for all the mathematicians. And on the behalf of all the participants who are the mathematicians, mostly we pay our thanks to these two beautiful minds who talked for us. Thank you so much. And I am quickly inviting my HOD, who is the chairperson of mathematics department, and she is Dr. Kamar Rubab, and she is very supportive, and it is because she always support her faculty. And madam, you are this is your time, and be quick, please.
Assalamu alaikum, everyone. Thank you very much, Zil, and a lot of thanks, Ma'am Vice Chancellor and Sir Yavar Abbas Bukhari. It's my great pleasure to welcome to all of you on this one-day international webinar on challenges, innovations, and opportunities in mathematics, organized by Department of Mathematics, the Women University Multan. I would like to pay my thanks to my worthy Vice Chancellor of the Women University, Professor Dr. Usma Qureshi, for joining us from her busy schedule. Indeed, it is not possible to do any progressive and productive activity without her encouragement and unconditional support. I also extend my thanks to Sir Yavar Abbas Bukhari Sahab, Chairman Public Account Committee and Minister Baitul Mal and Social Welfare Punjab, for his precious time for us, and especially precious words for the mathematics. It's an immense pleasure for me to host this as a chairperson of Department of Mathematics, and welcome to my speakers of today who join us from all around the world, who are from the best universities of the world. I would like to thank Dr. Kamran Somro, Senior Lecturer from University of the West of England, Bristol, United Kingdom, Dr. Aisha Asloob Qureshi, Assistant Professor at Sabnachi University, Istanbul, Turkey, Dr. Fiza Zafar, Focal Person for Women in STEM at BZU, Associate Professor Kasfam Bahauddin Zakariya University, Pakistan, Dr. Nila Boto, Associate Member of the Group Astronomy and Dynamical Systems, Visiting Scientist at many prestigious institutes, Associate Professor, DME Institute di Matematica, and Adjunct Director of International Relations, IM University Federal de Rio de Janeiro, Brazil. Dr. Fatima Artral, member of Directory Board of the Brazilian Organization for Women in Science for the Developing World, Adjunct Professor at the Federal University of Rio de Janeiro, Brazil. Dr. Muhammad Hadi, Shekures, Assistant Professor, Shiraz University, Iran. Ms. Wajia Rahman, Marie Curie Early Stage Researcher, University of Leeds, UK. Dr. Fatima Saharzadi, PhD, University of Nantes, France, Postdoc Research Fellowship, Zheng University, China. My special thanks goes to all of our speakers for their precious time for this noble cause of the welfare of students, and it is honor of Mathematics Department to host you all. I want to highlight that Mathematics Department, Women University Multan, is going to start its first session of MPhil degree program this year, as BS and MSc programs are already being offered by the department. I am blessed with hardworking and visionary faculty. In the end, I appreciate Ms. Elisham's lecturer, Department of Mathematics, WUM, to make it happen. Very best wishes for students and to all of you. Thank you very much.
And thank you so much, ma'am, for your precious words. And we are already late for some minutes. And here I am going to introduce our first speaker. And today we are having Dr. Aisha Asloob Qureshi. And let me introduce her quickly that she is the MSc and BSc gold medalist, and she is a doctor in mathematics, and she is doing her work related to the algebra and commutative algebra. She is awarded 3 times with the International Fellowship at the Abdul Salam School, Abdul Salam International Center of Theoretical Physics, Italy, and she is also got GSPS Fellowship at Osaka, Japan, Osaka University, Japan, and she is now the assistant professor at the Sapienza University, Turkey, and here she is.
Thank you very much, Dileshams, for such a kind introduction. I'm very happy to be here, and it's really my pleasure to be a part of this workshop. Thank you for the organizing committee for inviting me here. Can I please have the authority to share the screen? Okay,
yes, madam, I'm
let me
giving you
say.
access.
Miss Aisha, please unmute.
Okay, can you see the screen and can you hear me?
Yes, we can hear you and we can see the screen as well. Thank you.
Okay, great. Thank you. Thank you very much. Okay, so I was very pleased when Dilesham spoke to me to be a part of this workshop because first of all, it's a women university. So of course, I mean, I would have really preferred to be there and talk to the students, but this is how the situation is and we have to make the most out of it.
We'll invite you, inshallah. Please come and join us.
that will be a very big pleasure for me. Okay, so wait, I'm trying to manage my tablet here. Okay, thank you very much. So this is the first talk in the morning, in the beginning of the workshop. So I will not make it too theoretical, and it is aimed to reach out our young students, you know, who are studying mathematics in their bachelor's or in early master's stages. So my aim is just to introduce a little bit about the topic, combinatorial commutative algebra, just give a brief introduction and some motivation that, okay, normally when this is one of the main questions, you know, when we are studying pure mathematics and for example, if you apply for a job and even if you are trying to explain what you are doing, so everybody would ask you that, oh, okay, so what is the application? Or you are doing algebra, is too theoretical, is too pure or too abstract. So what are the applications? The first thing is that, okay, I mean, curiosity is the essential part to develop anything new. And in pure mathematics, okay, we are developing these tools that later one can use in applied mathematics and make, you know, several different applications out of it. And since it is a half an hour talk, I will try to be very brief. So let's move to the mathematical part of the talk formally. Okay, so let me. So what is commutative algebra? So commutative algebra is a branch of algebra where we study commutative rings. Ideal theory in commutative rings, modules over commutative rings, which can be seen as generalization of vector spaces over a field. And commutative algebra goes parallel to algebraic geometry and algebraic number theory. And by the way, by here saying commutative, it simply means that the multiplication structure on the ring is commutative. That is AB is equals to BA. So one of the most commonly known example here would be ring of integers. So we know that if you multiply two integers, whether you multiply, for example, 2 with 3 or you multiply 3 with 2, you will get the same answer. So AB is equals to BA. And as a counter example, one can see for non-commutative case, ring of matrices. We know that if you have two matrices, matrix A multiplied by matrix B would give you a different result when you multiply B with A. So the order of multiplication there matters. The other commonly known example of commutative ring will be polynomial ring in one variable or in several variables, where the coefficients are coming from a commutative ring or in particular a field. So roughly speaking, in easy words, when we are looking at commutative algebra, that how it is related in algebraic
presentation also as you speak.
Sorry, is there a problem?
Your presentation is static. If you could move this also as you
I know, no, it is. I haven't started yet. I'll move to the slide in a moment. Okay, so yeah, so roughly speaking, so in algebraic number theory, we mainly focus on ring of algebraic integers, while on algebraic geometry part, we focus on Noetherian local rings, giving a simple example, which means that polynomial rings again over a field. By saying Noetherian, it means that every ideal needs to be finitely generated, and by saying local means that you have one unique maximal ideal. So this is the classical introduction of commutative algebra, maybe a little bit too theoretical for our young students. So let's move to the combinatorics part. So what combinatorics has to do with it? So in combinatorics particularly, when we talk about, for example, enumerative combinatorics, the history goes back to centuries. For example, distribution problem. You have R objects and you want to distribute it among N boxes. In how many ways you can do it under certain conditions? For example, let's say your objects are identical or they are distinguishable. Similarly, if your objects, the boxes are identical or distinguishable, or even in more simpler words, if you have N objects and you want to arrange them in a line or around the circular table, in how many ways you can do it? This is like a very simple example what enumerative combinatorics is about. Then later on, there is integer partitioning. That is like another branch of combinatorics, where Ramunajan has actually a lot of contributions. Then another recent developed branch of combinatorics or discrete mathematics is graph theory, whose origin with origin in famous 7-bridge problem proposed by Euler in around 1770s, if I remember it correctly. So what do we do there? Okay, just give me a moment. Now I will use my tablet. So what do we do there is the following. So, okay, now I can use it. Thank you. So, so by saying this 7-bridge problem, I will just simply translate it without giving much of the background. But please, if you don't know about it, Google it. It's a very nice history. So as a child, you might remember that, you know, we were playing these games that you have, for example, a figure here, and you want to draw it without lifting a pen. So can you draw this figure without lifting a pen? For example, one way of doing that will be the following. But can you draw this figure such that you start and end at the same point? This is what this 7-bridge problem was about. And to be able to answer this question, that what kind of these figures where you have these nodes and lines connected or curves connecting these nodes, when you can draw them without lifting up your pen, and in particular, when you can draw them where such that you start and end at the same point. This was the first problem, the problem studied by Euler, which basically gave birth to this formal area of graph theory later on. While the answer of this one, as you might know from the first few lectures that we deliver in discrete mathematics, the answer of this problem is that, okay, if every node here is connected to even number of edges or curves, then it is possible. For example, here you cannot start and end at the same point because here it is connected to odd number of edges. Okay, so this is a little bit about graph theory. So now what we are doing here with this commutative algebra, commutative rings, and relation with graph theory, let's go in a little bit detail about that. So if you have any question, you can ask me in the chat. But please, if it is not any question, so otherwise I will get distracted. I will think that there is a question. So if you have any comments, please, I would prefer it that if you can continue it after the talk. Okay, so following the work of Richard Stanley, in the late 1970s, this new trend started, studying of commutative rings in relation with the combinatorial structures. So he was the first to develop this bridge. And for this, a very nice monograph is his paper, How the Upper Bound Conjecture Was Proved in Annals of Combinatorics. It's a very, very nice, not actually more like a mathematical article, but I would say an autobiography, that as a high school student, how he became interested in these combinatorial problems. And he's just out of curiosity, and he got then later on interested in upper bound conjecture, and then he developed this new technique, which is now formally a sub-branch of commutative algebra. It's a very nice read available. I mean, you can search over internet. It's free to download. It's a very nice article and very motivating also for, I mean, as a young student to read it. Okay, so now let's formally see what exactly he did. So let's fix a field K. So roughly speaking, what is a field? You have a group structure. You have two binary operations that normally we call addition and multiplication. And this field has both structures defined on it. So it's a group under multiplication and addition, and then multiplication is distributive over addition also. Then we consider a polynomial ring in several variables. Okay, so you have n variables. And what do we mean by saying polynomial rings? Even if you don't know much about the ring structure or the group structure, it is okay. Just think about simple polynomials that we are all familiar with, you know, studying mathematics. So what you are doing, you have variables, you take their products, and you take their sums, and your coefficients are coming from wherever your scalars, that the field that you fix in. Okay. So what is a monomial? A monomial is just simply product of variables. So for example, x2, x4 square, x5, it is a monomial. Now, what is a square-free monomial? Where you take product of distinct variables. So x2, x4, x5, for example, you don't see a power of a variable. Even in more general terms, you can think of it as prime numbers. So square-free integers. For example, 6 is a multiple of 2 and 3. There is no power of a prime that appears in the factorization of 6. Okay, so this is exactly, in some sense, we are doing here. So monomial, you just multiply the variables, look at it as a as prime numbers, and then for square-free monomials, you are multiplying distinct variables. Okay, so what do we do with these square-free monomials? You take a finite set of square-free monomials in your ring. There are two classical structures that we define on them, that we relate to them. One is the square-free monomial ideal generated by these monomials. So what does that mean? Simply speaking, it means that you take this finite set of monomial and you write, in rough sense, all of their linear combinations where the coefficients are coming from your polynomial ring. So that would be simply, in simply speaking, that what is the ideal generated by them. On the other side, one can also define a what we call toric ring, which has a translation as toric variety in algebraic geometry. So what would be a toric ring? That again, you take linear combinations of these monomials, but now your coefficients are coming from the field. They are scalars, so they are not, you cannot multiply them with their arbitrary monomials in your polynomial rings. Okay, so these are two classical structures that we can define. We can structure on the, this finite set of monomials. Okay, now let's take a set of n integers, first n integers, 1 up to n. Then one can define a simplicial complex, which is in some sense, it can be seen as a generalization of a graph, okay, roughly speaking. Actually, graph is a particular case of simplicial complex, but anyway, okay, so how do we define it? You have a set of n integers, and then you take a collection of subsets. Okay, so you have n integers, you can consider their power set and just choose some of the subsets there. Okay, so this collection of subsets, we call it a simplicial complex, first of all, if it is non-empty. And then whenever you have a subset in your collection, let's say F, it belongs to your collection, then all the subsets of F should be again in your collection. Okay, and then the maximal elements of your collection will be called facets. Okay, this is a formal definition, but it is always better to see these things with some examples. So let's look at it, one example of a simplicial complex. So for example, here, okay, so here 1, 2, 3, 3, 4, 5, and 2, 5. These three sets are maximal, so they are the largest set. They are not contained in any other set, so they are the facets. And now, by looking at the definition of simplicial complex, whenever you have a subset, so for example, 1, 2, 3, I am taking it in my collection. So now I have to take all the subsets of 1, 2, 3 as well. So all the subsets of 1, 2, 3, for example, 1, 2, 3, 1, 3, 1, 2, 2, 3 in empty sets, they are all inside my collection. Similarly, for this is what we do for 3, 4, 5, and 2, 5. So you pick some sets and then you take all of their subsets also, put them together, and this is your simplicial complex. And one can one can have a geometric realization of this set also. So for example, here, this is how I can present this collection of subset delta. So what we are doing here, I hope you can see this shaded region here. So this maximal sets, facets 1, 2, 3, 3, 4, 5, and 2, 5. Here 1, 3, 5 is shaded. So it is in my collection. 3, 4, 5, 4 is shaded, and once they are there, all of their subsets are also there, which means all of these points and the edges, they are also inside it. You can see that 3, 2, 5 is not shaded because it is not in my collection. Okay, so we can draw this simplicial complex also. Then what we do with this simplicial complex, now how this commutative algebra comes into play. So you take a simplicial complex, let's say on n vertices. So your vertex set is n, the integers from 1 up to n. What we do, we attach a polynomial ring to it with n variables. If you have n vertices here, you put a polynomial ring with n variables. Okay. Then, in general, what we do, to any subset of these n integers, we can attach a square-free monomial. So for example, if I have a set 1, 2, 3, I can put this monomial to it, product of x1, x2, and x3. So when you have this kind of a subset, you can attach this kind of a monomial to it. Okay, so the variable with indices coming from your set. Okay, and now, given your simplicial complex, you look at these maximal sets. Okay, the sets with that are not contained in other sets, so they are maximal with respect to inclusion. Then you construct your monomials with this identification, and then you generate an ideal with them. Okay, so this is an ideal now generated by square-free monomials, a facet ideal. Moreover, one can do a little bit reverse procedure. One can generate another ideal by those elements, those subsets that are not in your collection, that do not belong to delta. So in this way, we can attach these two square-free monomial ideals given a simplicial complex. Okay. This ideal that is generated by the elements that do not belong to delta is the one that was studied by Stanley, Richard Stanley. And this is called a Stanley-Reisner ideal. And later he used this construction in the proof of upper bound conjecture. I encourage you to read a little bit about it. I cannot talk about it because it needs some formal, more preparation. But in the end, okay, this is the idea. So after he introduced this structure, then it started a trend that, okay, now we have these square free monomial ideals and we want to learn, we want to know all these, their algebraic properties, their homological properties about them. So can we translate these properties in terms of combinatorial structure of the simplicial complex? So this is the idea. Okay, before going further into detail, let me give you an example here. So this simplicial complex that we took, here, as you can see, so here the maximal faces were 1, 2, 3, 3, 4, 5, and 2, 5. So this is my facet ideal here. And then the elements that do not belong to it. So for example, 1, 4, you can see that it does not belong to my simplicial complex. There is no edge between 1 and 4. So this is, for example, one of the non-face, one of the elements that does not belong to delta. So this is a very simple example where you can see the facet ideal and the Stanley-Reisner ideal attached to a simplicial complex. Okay, now giving one very simple example that, okay, how are we translating these combinatorial properties of the simplicial complexes into algebraic properties? So for example, when we look at the dimension, of this Stanley-Reisner ring, the quotient ring, if you have taken first course in abstract algebra, then you might be familiar with the structure of the quotient ring. So here we are looking, we want to compute the dimension. By saying dimension, we want to find the maximal length of a chain of prime ideals. Okay, it's generally, okay, it takes some preparation to define it and then to compute it. But by looking at the simplicial complex, one can easily say that what would be the dimension. So that will be that comes from the size of the maximal size of a facet. So if, for example, in our example, you saw that 1, 2, 3 was a facet, it was one of the largest facet. It has 3 elements, so its cardinality is 3. So the dimension of the simplicial complex will be 2. So the size of the maximal face of with the maximal cardinality -1 gives you the dimension, the length of the longest chain of prime ideals in your ring. And then in similar way, one can define the, one can interpret the other algebraic properties with the combinatorial structure of simplicial complex as well. Okay, so I still have some time, right? Okay, so now given a simplicial complex, one attach a square free monomial ideal to it. And actually there is one-to-one correspondence. So every square free monomial ideal, it can be seen as a Stanley-Reisner ideal of a simplicial complex, and to every simplicial complex one can attach a square free monomial ideal. So there is one-to-one bijection, which gives equal weightage to the study of both the structures, and you want to translate the combinatorial property into algebraic sense and the algebraic properties into the combinatorial sense. Now, as a particular case of it, which is actually quite general in itself, we look at this particular, like the graphs, instead of simplicial complex, where you have faces of large cardinalities, we rather look at the graphs. So what graph theory has to do with commutative algebra? Okay, so we take a simple finite graph by saying simple, there are no loops, there are no multiple edges, it's a finite graph, and there is a vertex set, and then there is an edge set. And then one can associate, again, an ideal with the same idea that we did with the simplicial complex. If you have an edge in your graph, if there is an edge ij in your graph, you attach this kind of a monomial to this edge, and then you generate this ideal. What would be special now? In Stanley-Reisner ideal or in facet ideal, you can have monomials with more than 2 terms, monomials of bigger degree. But when we are looking these edge ideals, because in graph you have your faces which are edges, their sizes are only 2. So this edge ideal is generated only in degree 2. So all the generators are product of only 2 distinct variables. Okay.
Dr. Aisha?
For example here.
Yeah, you have to close the talk within some minutes.
Okay. Can you tell me in how many minutes?
As early as it is.
Okay. Okay. So, for example, here, if you have 4 vertices here, and this is your graph, 1, 2 is an edge, so you have this edge here. 1, 3 is an edge, so you have this monomial here. So in this way, one can generate an edge ideal. And then again, the idea is to look at what is happening in the combinatorial structure of the graph, and then see if we can answer some algebraic questions related to these ideals. A particular case. Okay, so what is a coloring of a graph? Coloring of a graph is such that, okay, you have now a graph and you want to color its vertices such that if 2 vertices are connected via an edge, then they should get a different color. A very simple example that why coloring of a graph would be important to know, a very, very simple naive example would be, let's say you want to schedule exams. Okay, students are taking different exams and now we want to schedule their final exams. So if there are 2 subjects that a student is attending, 2 courses, then these exams should be planned in different time slots so a student can attend both the exams. So not to create any time conflict, for example, you can look at these 1, 2, 3, 4 as exams, okay, as a courses. So course 1, vertex number 1 represented. Course 2 is represented by vertex number 2. And then you connect 2 exams, 2 vertices, if there is a student who is taking both of these courses. So now by saying connecting 1 and 2, it means that there is a student who has to take exam number 1 and 2, so we should schedule it at a different time. Okay, so what is the minimum number of time slots that we will need? That will be the minimum number of colors that you need to color this graph. So for example, here, if we have 4 exams to schedule with the connections given in via edges, you need at least 3 different time slots so that there won't be any time conflict. So just a very simple, naive example, as I said, that why coloring of a graph would be interesting to know. Now, in terms of, again, coming to the algebraic side of it, we define the minimal vertex covers of a graph. What does it mean? It means that we are taking a subset of vertices such that in subset, you do not have any edge contained in it. So, and then given any such vertex cover, one can again associate a monomial by the same idea. You take the product of the variable whose indices are coming from your subset. And then one can generate an ideal that we will call now cover ideal. So we already defined edge ideals coming from the edges. We can define vertex cover ideals coming from the vertex covers of the graph. For example, again here, the edge ideal comes from the edges 1, 2, 2, 3, 2, 4, and so on. And cover ideal is given by here because one can see that if I take the vertex 1 and 4, so 1 covers all these 3 edges, 4 covers these 2 edges. So this is a vertex cover. Similarly, 1, 2, 3 is a vertex cover. So we take the smallest in size, we take those vertex cover, generate an ideal with it. And then one can see that, okay, let me actually come to the main point here. So the chromatic number of the graph, which is, let's say, not so easy to compute in general, especially when your graph has many vertices and many edges, if it has a bigger order. But there is a way to look at this chromatic number in an algebraic sense. You take its vertex cover ideal, and then you multiply this ideal with itself, let's say up to d times. If in this ideal, which is the dth power of your vertex cover ideal, you see this monomial, which is the product of all variables raised up to d minus 1 power. If it belongs to the dth power of your vertex cover ideal, we take minimum of such d, that gives you the chromatic number. Now, as an exercise, you can try to compute it for some simple classes of graph, for example, for a cycle or for a planar graph, where we know the chromatic number should be 4. Okay, now moving forward, okay, apparently I already ran out of time because I started a bit late. I would like to say a little bit about binomial ideals. So this is what we are doing for monomials, but in polynomial ring, we have, polynomials with many components in it. Can we do this combinatorial computations? Can we associate this combinatorial structure, not just for the monomial ideals, but also for arbitrary polynomial ideals? For arbitrary polynomial ideals, yeah, it's a little bit complicated, but at least for binomial ideals, there is a way to do it. So what kind of binomial ideals we are looking for? You take a matrix. For example, here you have 6 rows and 5 columns, and your entries are variables. And then we know from linear algebra how to compute the determinants or how to compute the cofactor or minors of a matrix. So for example, here, if I choose the minor coming from the 5th and the 4th column and the 2nd row, so here your entries will be the blue ones highlighted, x22, 24, x52, and 54. The minor will be the determinant of this submatrix. Okay, now you can see it is a binomial, a polynomial with 2 terms. Bi means 2, binomial. Mono means 1, monomial means 1 term. Polynomials, many terms. Okay, now, for example, here you have this matrix, and with this red entries, here it means that I am taking this shape. Now I just want to compute all the possible 2 minors that I can make in here and generate an ideal with it and see what are the properties. Why these ideals are important, by the way, they have immense applications in algebraic statistics, in studying conditional independent statements and so on. So they're basically the idea of this square-free binomial ideals. The importance of these ideals come from. Okay. Now, going back to it, one can attach these polyominoes to it. So what are polyominoes? As a child, we have all played at some point Tetris, these dominoes, so these objects that flying from the top of the screen, and you want to arrange them in the bottom. So from there, you might remember these kind of figures. So they are called polyomino. Unit squares join edges by edges. We can consider these shapes now inside our matrix. So, okay, so there is a reference also for anybody who is interested. I can send them it to them later. So the first connection of these polyominoes with binomial ideals, it was given in one of my early papers. Okay, now let's go to go back to this example. So for example, this is now you can see this red shape, it determines a polyomino. Now we would like to study the ideal that is associated to it, the ideal generated by all the 2 minors. What one studies for this ideal? Well, first, we would like to study Grosvenor basis. Grosvenor basis is now a fundamental tool that we study in integer programming, in linear algebra, to see that given a polynomial, whether it can be written as a linear combination of some other fixed polynomials. And in commutative algebra, or in general in algebra, it plays a vital role. Okay, then minimal free graded resolution. That has something to do with the homology of the quotient ring, looking at it as a module. Then compute its regularity, checking whether it is normal, Cohen-Macaulay, and Gorenstein, all these invariants coming from the graded free resolution. If you don't know about it, don't worry about it, just think of them as some algebraic and homological concepts here. So again, given this given this matrix and this shape, this is my polyomino attached to it. So I took this part and I drew it here. And then this is the ideal generated by 2 minors. So for example, for this one, I get 2, 2 minus 3, 3. This one, 2, 3 minus 3, 2. Similarly, for each submatrix here, I will attach a binomial. So for example, here also I have this submatrix. So for each submatrix that you see here of size 2 cross 2, you put this binomial and then you generate this ideal. Okay, Zileshans, if I'm out of time, please let me know. Then I will just give the final.
Yes,
I don't want to take the time from the other speakers.
Yes, we are out of time. Actually, we have to follow the schedule, and I'm sorry that you are given with the short time. Then
no, it's okay. Okay, I will just finish the main idea here.
Sure, please.
So we have this binomial ideal, and of course, I mean, given these algebraic properties, okay, the motivation coming from algebraic geometry, the terms that we call Castelnuovo for regularity, which comes from the resolution, so let me actually show it to you here. So given any homogeneous ideal in a polynomial ring, we consider this kind of an exact sequence. Okay, you might have seen exact sequences in group theory, for example. And then this regularity, this invariant is coming from this kind of a resolution. Okay, in general, it is not so easy to compute. From monomial ideals, one can say a little bit more, but when this I is a binomial ideal or polynomial ideal, even a binomial ideal, it's not so easy to describe. So for example, why we are doing this, like putting an ideal and trying to make a funny picture, associated to it, what is the point? Polyominoes can be seen as chessboard configuration. In chessboard, you have this black and white alternative squares joined together. And then these kind of structures, okay, they give us many questions in combinatorics that, okay, how would you put, for example, rooks in them if you have a pruned chessboard configuration? By saying putting rooks, it means that, okay, rook from the chessboard, from the chess game. So in one row and in one column, there should be only one rook. So given such a configuration, which is like a little bit cut from maybe from the corners, how many rooks we can put there? Like here, if I have this kind of a configuration, which can be also seen as polyomino, I can put 2 rooks if I put it like that. But can I rearrange them to put more rooks? For example, here, now I can put 4 rooks. Given a more complicated such a polyomino or a chessboard configuration, in general, it is not so easy to find how many rooks are you going to put. And why we are interested in putting these rooks, because they are giving us that, how many columns and rows independently we can pick, how many cells we can pick from each row and each column, coming from, the motivation coming from several reasons. Now, looking, this is one of our recent work which relates these regularity that comes from the minimal graded free resolution, and then you make a lot of effort for this quotient ring here coming from the polyomino ideal. This homological invariant is exactly the number of maximal rooks that you can put in a polyomino. And then this is a question coming out of a complete curiosity, and then relating these two ideas coming from combinatorics and algebra together. And then similarly, one studies the other algebraic and homological invariant, and also some combinatorial question that whether we can use algebraic tools to answer those combinatorial questions. So this is just a brief idea of the of this subject. And if there are some interested students, please feel free to write me if you want to know about the references or any further detail. Thank you very much. Thank you.
Thank you so much. And she was Dr. Aisha Asloub Qureshi. And one thing I want to mention that she have 22 articles, research articles in her field published, and there are a lot of research work is waiting to be published by Dr. Aisha Asloub Qureshi. And we hope that she will collaborate with the Pakistani mathematician, as she is also a Pakistani native, and she will help us in this regard. And we are very thankful. I am on the behalf of Department of Mathematics and from the Women University Multan. I am very thankful, madam, for your precious time and for your great ideas. Thank you so much, and good luck.
Thank you very much.
And here I also want to announce that Dr. Usman Ali, who just joined us, and I want to mention that he is now the director of sub-campus, the Bahauddin Zikriya University Multan. And sir, you have just 2 minutes before our second speaker to please highlight that about the mathematics and about the mathematicians. And here the Dr. Usman Ali, director of sub-campus Vihari. Dr. Usman Ali, we are having Professor Dr. Uzma Qureshi, the Vice Chancellor, Women University Multan. She is also with us, and we are having speakers, and the chairperson of Department of Mathematics, the Women University Multan, is also with us. And Dr. Fiza Zafar, Muhammad Hadi Shikharis, who is from Iran, and Dr. Fiza Zafar from the CASPAM. Bahauddin Zikri University is also with us. Yeah, thank you, sir.
Welcome, sir.
Thank you for inviting. And I just joined and I was listening a very good talk from Aisha Aslu, Dr. Aisha Aslu. And I was a bit annoying that you are not giving her proper time because she was discussing very important things and the interplay between combinatorics and algebra. And
I think
should
we have given a very good advice.
rewind
We
and
will have a separate lecture by you.
What?
Sir, you have given a very good suggestion. We will have a separate session, invited session with her, so that students can
very
learn
separate
about our
session for
area
her
in depth.
because she is a very good expert and especially in Grosvenor basis and for Zilli Shams as well, because Zilli Shams is also dealing with some chromatic number, not the ordinary one. So you must invite her for a separate session to talk about in detail. And so you can proceed further. I'm here to listen, to be a participant here. Good luck.
Thank you so much. Thank you so much. And I want to tell that Dr. Usman Ali is not only a director of sub-campus Vihari Bahauddin Zikri University, but he is also a good mathematician. And he is here because he is a very good and renowned mathematician, and he is associate professor at Bahauddin Zikri University as well. Thank you so much, sir, for your precious time, and hope we are looking forward to you for our students. Obviously, you will create some good position, and you will create some good you will have some good collaboration with the Women University Multan, and we are looking forward to you. And thank you so much. And let me introduce, I am taking no time to introduce our second speaker, and I am very excited to introduce her. And she is Dr. Fiza Zafar, and she is a brilliant mathematician of our soil. And Dr. let me introduce her background. She has so many achievements. She is a gold medalist in MSc and in BSc from this board, Punjab board, and also she is an associate professor at Bahauddin Zikri University Center for Advanced Studies, Pure and Applied Mathematics. She did her PhD from CASPAM, and then she did her postdoctoral from the Spain. Sorry, ma'am, the name was so difficult, so I am a bit afraid to speak. You will tell to the participants later.
And there's no need to go for the long introduction, I think.
No, I'm just highlighting that you are having so many achievements in this time. You are having a bright academic career, as well as you are a good teacher for this region, and you are really a great mathematician. You are having so many publications. You are having 55 international publications with the impact factor of 37.14, and you are doing a lot of us. And the special thing is that you are very near to us, and we can approach to you at any time, and this is our blessing. And thank you so much, ma'am, and this is your time.
Thank you so much. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, and good afternoon to everyone. Thank you, Zilli Shams, for the nice introduction. And first of all, I would like to extend thanks to very dynamic and worthy Vice Chancellor, Professor Dr. Usman Mahmood Qureshi, and then the Chairperson, Department of Mathematics, Dr. Kamar Rubab, Zilli Shams, also the wonderful my students and faculty of Department of Mathematics, Women University Multan. Thank you for having me here, and thank you for offering this platform not only to me but also to the mathematics students of South Punjab. Can I please share my screen? So it is visible to you?
Yes, ma'am, it is visible too. I hope to everyone.
Okay, thank you so much. And I'm very pleased to be here, and I'm very pleased that my talk is followed by the enlightening address of Professor Dr. Uzma Mahmood Qureshi, as well as Sayyid Yabar Abbas Bukhari, Minister Social Welfare and Baitul Mal. That is because that address would have given you a very, very clear idea that what government and administration want from us. Not only in the capacity of being students, but also in the capacity of being scientist or being a faculty member at any of the higher education institute of Pakistan, as well as if even you are teaching at the primary or secondary level, even then you have to be very, very clear. You have to have the clear idea that what you have to deliver to your kids. The title of my talk today is Mathematics for Sustainable Development in Pakistan. And I'm also happy that I'm accompanying here with a very, very wonderful speakers, Dr. Aisha Abbas, who was, she was trying to divert your attention actually towards decision making and transportation and networking problems. Then Dr. Kamran Sumro has to follow, who would be talking in machine learning. Dr. Fatima, who would be talking neuroscience, and also Dr. Fatima Sehet, and then Ms. Wajiha, Dr. Muhammad Hadi. So I have a very, very good set ground for giving this talk, although it seems to be very, very different when we say that sustainable development Pakistan. Some of us may think that it is the topic of social sciences and civic engagements, but now you have the idea from the address of the top minds of Pakistan that it is connected to us as well. I'm sorry if I can.
Assalamu alaikum, ma'am. You are muted.
I'm sorry. So I was saying that not only the people of Pakistan, but especially in Multan, they can relate well to this picture that I am putting in. That as the Special Assistant to Prime Minister on Climate Change, Malik Amin Aslam, on Friday said that Pakistan is declared the hottest region of art at the moment by WMO. So the question arises in our mind that what we can do in our capacities. And many people in the area of mathematics are convinced that sustainable development and mathematics are completely unrelated. But you now have a very small idea that they are not, and they need each other. Before moving further, because this is a very unconventional topic, I would like to define sustainable development. The definition was given by World Commission on Environment and Development, that it is identified as a development that meets the need of the present without compromising the ability of future generation to meet their own needs. The three dimension of sustainable development, they are social, environment, and economic. And if we talk of the conventional approach that is followed at the international or global level, right from the start of the 21st century, the 8 Millennium Development Goals were given by United Nations in their Millennium Summit in 2000, and then later in 2005, the decade of Sustainable Development Goals, they were given. Sorry, there is a problem with the screen sharing. Yeah. In 2005, the Decade of Education for Sustainable Development was signed, and in 2015, the United Nations approved Agenda 2030, which set out 17 goals for sustainable development, which are normally called as SDGs. And talking of about Pakistan, the priority goals for us, they are 3, 4, 6, 7, 8, 9, and 11. Now, this calls us to how do we implement this in the academia, especially in the higher education. This calls us to the education for sustainable development, the terminology called as ESD, which has the key points that higher education must include training in sustainability to make us aware of the serious problems our planet is facing. Everyone must be aware of it. And the university has the pivotal role in moving towards sustainability in the context of education, following these ESDs. The STEM faculty, I would not start with the mathematics faculty because now this is not the time where we remain isolated from the science, technology, and engineering, as well as innovation. We have to group up. So the STEM faculty has the responsibility, and they must lead the sustainability movement by providing appropriate content to the students, by developing knowledge, and by knowledge I mean skill development, and equipping them with the practical exposure. And these are also the key points that has been given by National Initiative on SDG in Pakistan. So the aim must be to transform knowledge in education for sustainable development into problem solving, critical systematic thinking, and action, which we call active learning or the practical exposure. So when we think about it, we say that we have to work on our teaching and research, but the idea here is that we cannot do it without improving our curricula. If we talk about the mathematics education for sustainable development, then usually we also use this approach that we call it meaningful. We call it, we have to deliver such education which is meaningful, which is helpful, which is supporting the 21st century competences. And then the conventional practices that when we talk of the mathematics education is that we have to embed into the students the critical thinking, the creative thinking, communication, and we have to be collaborative. So if we see this whole picture, we can find that the mathematics competences, they are the superset as compared to the competences of the ESD or the educational sustainable development. So it means that we are equipped with the right skill to make it happen. So we have to communicate in, with, and about mathematics competencies. Now, so what do we have to do in teaching? Because it is not a very short-term idea to throw in and to say that just to start with it. We can work with our present curricula. So first of all, the curriculum we have at our universities, we have to innovate teaching in calculus, differential equation, the basic mathematics subjects, the undergraduate, graduate, and postgraduate level. Then when it comes to differential equation, we have to attach it with mathematical modeling that most of the universities of Pakistan are doing. And then fluid mechanics, we know that we have a lot of experts in fluid mechanics. Then when we talk of the mathematics of decision making, and then the risk management and the disaster management, then it comes to the advanced topics of dynamic systems, chaos theory, control theory, and then you have, if you have attended the talk of Dr. Aisha, she was talking about the about the merger of algebraic structure, graph theory, and combinatorics. If we talk of because when we start thinking of the mathematics education at the university, we start with the undergraduate level. So it is more conventional to go along with the good practices in calculus, differential equations, and mathematical modeling. For example, when I teach mathematical modeling, I've been teaching it from the last 6 to 7 years. I use the approach exercising, and now with the advent of the digital technology, I am also using computer modeling like the very simple packages of MATLAB. And talking of a very basic level, you can take the exercises, the approach exercises from the population growth, and you can embed in them the concept of over harvesting, the resource management, the species extinction problem, the climate change, transportation models, the concept of smart cities, and of course, epidemiology, now all of us know, and then neuroscience. And next is the second pillar. And it is very important pillar because if we can start with changing our approach towards teaching, but we also have to improve our curricula to include the streams of data science, machine learning, big data analytics, business analytics, financial mathematics, mathematics and statistics of decision making, because the fourth industrial revolution that is followed by the digital revolution is the ongoing automation of traditional manufacturing and industrial practices using modern smart technology and machine-to-machine communication, the Internet of Things. Every one of us now have access to the digital world and networking. Now, if we want to incorporate these streams into the curricula of mathematics, of course, we have limitations. We have the limitations of credit hours in each semester. We have the limitation on the total credit hours of the degree, whether it is BS or it is MS. But if we are talking of the undergraduate curriculum designing, we have to be very different. We have to follow the very different and modern with the trend that is according to the modern need in the courses of linear algebra, multivariate calculus, numerical analysis, statistics, numerical computing, MATLAB, and Python, using now Python and R rather than along with I would say, because MATLAB also is essential, along with MATLAB, Python, and R. And as well as, because what we want to do is to create the think tanks at the level of the universities, in the academia. Okay, the think tanks would be working in the government sector, but the best we can do is to create the think tanks at academia, at universities, and also at the primary and secondary level. So we have to also train our students for the courses like teaching mathematics and primary and secondary level. This is also being addressed recently by National Mathematics Curriculum Designing, and many faculty from this primary and secondary level, they are being trained by the government to follow the modern needs. Next, we talk of the mathematics and sustainable development and the pillar of research. Now, what we can do at present is to link our undergraduate, graduate, and postgraduate projects, whatever we are doing, at whatever level we are doing, we try to link them with the SDGs. Like if we talk of the SDGs, SDG 3, good health and well-being, then we can give the applications or take up the projects even at the BS level. Take up the projects like you say that brain tumor modeling, and then connecting mathematics with because it is difficult to connect at this time with machine learning or with artificial intelligence because the students are not trained well enough to do this at this scale. But you can give mere ideas of these areas. And also the clean water and sanitation, as I was talking, that we have many experts of fluid mechanics, even at your department of mathematics at the WUM University Multan. I know that we have the faculty which are specialized either in fluid mechanics, or they are doing their research in the fluid mechanics. They are working in graph theory. So we can link up our research. We can try to link up our research with the SDG 6, for example, clean water and sanitation. We can go with the water management systems, then affordable and clean energy. So we can go for the networking and transportation models, like designing electrical power systems. So we have to link up with the engineering applications as well. And also economic, if we talk of the economic growth, that this leads us to financial mathematics, then SDG 9, industry, innovation and infrastructure. We have to go to the industry and find the projects that are in line with our expertise. And then SDGs 11, the sustainable cities and communities, so to link up with the digital world. And then climate action, we can go with the simple projects on climate control. And SDG 14 and 15, life below water on land, can be very well and easily modeled with mathematics, and different, and leading us to the problems of differential equations, ODs and PDs. Further, what we can do to excel, because of course we don't we don't want to be static, so we have to keep improving ourselves. So we have to adopt the eco pedagogy. We have to care for, respect and take action for all life. We have to link ourselves to all the possible opportunities. And also we have to link ourselves to the civic responsibilities. And as well as we can build ecosystems. We have many good opportunities around us. We have to go through our ORIX to develop industry academia linkages. At BZU we have very good full cooperation by ORIC. And then we can think of the interdisciplinary research institute at a later level, but we can think of interdisciplinary research at this level, linking up with the faculty of engineering, with the faculty of computer science, with the faculty of statistics, that we can do at present. And then later we can plan for the more good research institute where everyone can connect and excel. Then national incubation centers, we know that there is a buzz about this nowadays. So try finding the opportunities in there. And at BZU, we also have now initiated, we have been doing this, and National Incubation Center is connected to BZU now. And then national research, the grants, go for the grants, because of course it is very important to be financially sound to take up research projects like this. So go for the National Research Program for University, the Technology Development Fund, every such opportunity that the Government Higher Education Commission is offering to you. Now, if even if you say that okay, it is not possible in a small time, then what can you do? You can start now by teaching real numbers, real words, real problems in your classrooms, and make them the gifted classrooms. I'm putting here some books that I went through, and they have very good topics to teach and to link your undergraduate mathematics with the applications that are needed to be given to the students to enhance their capabilities, their capacities, their capacity of critical thinking, their capacity of linking to the problems that we are facing in our country and globally as well. These are the references that I used to come up to this talk, as well as I have put here some useful links which you need to go through as mathematics if you are in the capacity of being a mathematics faculty, or even if you are a MPhil or PhD scholar. You must have at least some idea about what is happening all around and how you can link up to the opportunities as well as to the present needs of Pakistan. So this is about SDG Pakistan. Then this is the Pakistan web page of UNESCO. Then this is the sustainable development in the sector of education, United Nations web page. And then this is something which I wanted to put in. I followed last year. This was the talks that put up the insights of sustainable development, how we can invest in science, technology, engineering, and mathematics. And they had a year-long activity, and this was very, very meaningful. And then this is a web page, website where there are small projects of mathematics at from early level to the advanced level that you can take up along with your students and to link up with the sustainable development and sustainable development goals. Thank you so much. I always say that we need to grow to care for ourselves, to care for others, to care for our country. And I would like to acknowledge here that this effort of mine is a consequence of, I'm very lucky to be at a workplace where I'm teaching with my teachers. So I am always guided by them. And I have no hesitation in saying that I am surrounded by very, very supreme minds. My faculty is very cooperative. My seniors, my teachers are very cooperative, and whatever I'm delivering here, it is a consequence of years-long activity that we have done in designing the first curriculum. I would like to say, I'm claiming this, but we know that we have worked hard to do this. So the first curriculum that is of undergraduate level as well as the MS level, at where we are embedding the streams of data science, financial mathematics, machine learning at the undergraduate level. We know that some of the universities, the federal universities, are doing this, but as far as the universities in Punjab, especially in the South Punjab, we are lagging behind. So we have to put up efforts to now come up with the curricula that can address our present needs and demands. So at BZU, at CASPAM, we are in the phase of implementation of this curriculum. We, inshallah, will be offering it from spring 2021, and of course, it will be a very, very good opportunities for all of us, that the mathematics faculty, the students in the South Punjab region. Thank you so much. Thank you so much for having me.
Thank you, Dr. Fiza. Thank you very much for your kind words and your precious knowledge, precious time. Thank you very much.
Thank you, Dr. Kamar. Thank you. And I would like to congratulate the worthy Vice Chancellor, Professor Dr. Usman Mahmood Qureshi, your good self, Dr. Kamar Rubab, Ms. Zille Shams, who is a focal person of this session, the whole activity, And I hope, because the speakers that are going to follow me, they will be talking in the similar lines. And you would see, you would be able to link up to this talk. And at the end of the day, inshallah, I think the message would be conveyed. So thank you for having me here and giving me this platform to share whatever I wanted to share. Thank you so much.
Thank you. Dr. Aisha Asloob's talk was also very impressive.
Yes, she was leading us towards the decision making. She started with a very good application, and I'm very sure that I am looking at topics, and they are very excellent topics, and they are needed to be addressed at par.
Thank you so much, Dr. Fiza, and thank you for creating the opportunities for this region and for the women, and especially you were focused that how can we move to the practical life of the mathematics, and we should be not only focus on the theory, but we should go for the problem solving, and definitely we will be in touch with you for the future, and it is our blessing that you are near to us. Again, I am repeating this.
Thank you so much. Thank you so much.
Yeah, I'm again repeating this statement, and thank you for your precious time and your kind words.
I'm very happy. All of my students, my peers, they are doing a very good, very wonderful job.
One thing
congratulations to all of you,
Thank you very much, Dr. Fiza. Thank you very much, Dr. Fiza, for writing connections of mathematics and sustainability. I have a question here for you. How the Ministry of Science in Pakistan played their role to enhance the culture of such type of projects in Pakistan? What do you think? What necessary steps they have or they should take to enhance such type of culture in Pakistan?
I think they are doing their role. We from the past year, we are seeing the opportunities like National Research Program, the Technology Development Fund, the big amount of financial assistance that they are offering through Higher Education Commission. Of course, it is the consequence of the policy making at the higher level. What we have access to that comes from the top to bottom. So I think they are playing their role. And also you would be aware about the now associate degree programs, the policies that HEC is now conveying towards us. The associate degree programs are there. Then they are talking of the curriculum designing according to the present needs, and not only at the level of the university, but also in the primary and secondary education sector. So it means so things are happening there. Of course, we don't have the direct access towards but there are some web pages. When I browse, I come across with so many of the documents that covers all the policies that are being addressed at the top level. So it is now our role to go and connect to those opportunities, as well as those conversations that are being done at the top level.
Thank you so much, Dr. Fiza. And I am on the behalf of Mathematics Department, the Women University Multan, looking forward to the CASPAM, Center for Advanced Studies in Pure and Applied Mathematics, to have some collaboration on the institute level and create the opportunities for our girls to do same, like we are impressed, and we are also the student of CASPAM. And I also want to extend my welcome to Dr. Saima Akram Rana. She is also the assistant professor, if I am not wrong, and ma'am, if you do not have promoted yes to the associate professor, she is assistant professor at CASPAM. Thank you so much for your precious time, ma'am. Ma'am also joined the session, and I also want to extend Yeah, I also want to extend my welcome to Miss Humaira Awan. She is doing her PhD in graph theory from the Hungary Budapest University, and she is very good in her field. And she is also between among us, and she is giving her precious time. And the students may contact her for get the scholarships and to know how we can reach to the top ranked universities. Also, we are having here Rashid Ayub, who is the head of Department of Mathematics, Civil Line College, Multan. Thank you, sir, for joining this session. And I'm also pleased to having all these participants and this houseful session. And I am pleased that the people are paying attention that how can we connect the mathematics to the real life, to the real problems, and we are creating the opportunities in mathematics. And I am looking forward to the all participants to please make it possible for your real life. And now I am going for another speaker, and I am really very sorry that we skipped the time of our break and our tea, and because I do not have tea this time. And I am going to introduce another speaker of the day, and he is Dr. Kamran Sumro. Sir, are you here? If you are here, sir, please, you can unmute your mic. Yes.
Yeah, I'm here.
Yeah, okay. Now I'm going to introduce the Proud of Pakistan, Dr. Kamran Sumro. He is a senior lecturer in computer science in the Department of Computer Sciences, University of West of England and Bristol, United Kingdom. He also did his PhD from the University West of England, Bristol, United Kingdom. And especially he is the data scientist, and he is data scientist for the national health system in United Kingdom. He is also his interest includes the ICT technologies for the smart cities and the urban management knowledge and knowledge management and artificial intelligence and the big data, natural language processing, and many more. He is having so many expertise. And here the topic of his talk is applied mathematics in machine learning. And sir, looking forward to you if this is your time. Thank you.
Thank you very much. Yeah, that was a very good introduction. I think somebody needs to mute their mic. There's a lot of noise. Anyway, so yeah, as you mentioned, I'm Kamran Sumro from the University of the West of England in Bristol. And just to sort of mention right off the bat, I'm not a mathematician by background. I am a computer scientist. So I'm more of an applied, I apply mathematics in the work that I do, but it is not my expertise. So today I'll talk a little bit about how mathematics is applied in the area of machine learning and what role it can play. Hopefully the idea is to give you some, I don't know if you guys are familiar with what machine learning is and what is the purpose of machine learning and what it does. So I'll start with a little bit of background in machine learning and talk about what kind of mathematics is used in machine learning in general. And then I'll proceed to talk about a typical end-to-end machine learning project by using an example from a project that we did recently, a short project that we did recently. So I am a big fan of interactive sessions. So if you guys have any questions, by all means, interrupt me during the presentation, or I'm happy for you to turn on your mics and talk to me directly. I'm quite happy to engage with you. So yeah, and then within the machine learning project, there are different steps that a typical machine learning project includes. These can be like data cleaning, exploration, model training, model evaluation, and interpretation of results. And I'll talk a little bit about what these steps are and how we do them. So in general, there are several types of mathematics that one would need to know if they want to work in the area of machine learning. These include linear algebra, analytic geometry, matrix decomposition, vector calculus, probability and distributions, and continuous optimization. And as I go through my presentation, I will give you examples of a few of these to show you how they're applied in machine learning. So let's start with what is machine learning in the first place. So how many of you actually are familiar with machine learning? So how many of you actually know what it is? You can just say in the chat, just type in the chat if you want. If I can see it, I don't know where it went. Oh, there it is. Yeah. Okay, you are good. Have you ever done a machine learning project, Rafia? Not yet. Okay, no problem. Yeah, so machine learning, if we talk about the formal definition of machine learning, it is okay, what is CFD? Okay, so if we talk about machine learning in general, it is computational fluid dynamics. All right, okay, yeah. So the aim of machine learning is to design general purpose methodologies to extract valuable patterns from data, ideally without much domain expertise. So what we try to do is describe mathematical models of data. Well, describe techniques that allow us to create mathematical models of data sets that incorporate expert domain knowledge into those mathematical models. And a machine learning model, machine learning typically involves three core concepts. These are representing the data in a format that is computer readable, and describing a model and learning parameters of those models. So representing data is typically done by representing the data as vectors or tables. So in the form of rows and columns. This is a natural representation for machine learning because it allows us to divide the data into examples, and those examples are described by attributes. So columns in the tables become attributes and the rows become examples. So for example, let's say if we're talking about doing weather pattern analysis, so the rows of the table can be readings of different weather parameters on different days. And then the columns are the different weather parameters. So humidity, precipitation, I don't know, temperature, things like that, wind speed. So that in that way, we represent the data as vectors, and this becomes a natural representation for us to process that data. Then models are predictors, and in other words, they're mathematical functions that transform input data to output. So that's essentially what a model is. The idea is to describe sort of design a mathematical function that will take those input data that we have in the form of tables and transform it into outputs that give us some information. And then training or learning is the process of finding parameters for the predictors that minimize the loss. So those predictors or mathematical functions will take certain parameters, and the training process is the process of identifying what those parameters are or what their values should be. And the loss is basically the error in our output, which is to say how far from the actual ground truth our outputs are. So in the training process, we try to minimize the loss. And so we do that by varying the values of the parameters. And so we try to find the optimum values of the parameters. So I'll give you an example. So we have, if we want to predict, let's say, house prices, and we have a number of, if we have, let's say, house prices for different sizes of houses, like in this manner, and we were to ask, okay, can you tell me what would be the expected price of a house if for a 4,000 square feet house, or let's say for a 5,000 square feet house? So the way this is typically attacked using a machine learning approach is that we want to identify the trend in the data. And a typical form of machine learning that we can use here is called regression analysis. I don't know if you guys have heard these binary. I just want to ask binary digits as a code in special message code to deliver in a special form. Farhana, can you explain what you mean? Sorry, I don't understand the question.
Sir, Assalamualaikum. Sir, I just want to ask the questions in the special agents binary digits 01 code word used in the computer. How many other methods to use to send the message in code words?
If you're talking about data transmission, that's always done in 0 and 1 format. Computers always deal with binary digits 0 and 1. So I mean, yeah, that's the language of computers. So I'm not sure what that would be. Yeah, Imran, I'll share my email at the end. In the presentation, you can take it from there. So I'll just yeah. So to give you an example here, so what we're trying to do is identify this trend that sort of identifies the mean of the values. Not well, it's not the mean, but it defines the trend of the values for the different square footages. And so what we want to do is identify this line. And from, if you must know from geometry better than me that a line can be represented in the general format like this, theta 0 plus theta 1x, where x is the slope of the line. So if we, in mathematical terms, we want to identify these parameters, theta 1 and theta 0, that will describe this line and allow us to identify this trend in the data. So the training process in this case in regression analysis is to identify the values of theta 0 and theta 1. And that is done by basically, well, there are different algorithms that you can do. One is a popular one is gradient descent, which starts with random values, and then it measures the error. The error in this case would be, so these are our predictions for the square footages for the prices of the houses for different square footages, and these are the actual values. So the error is measured by the error is basically the difference between these values at each point. So we want to define a line that has the minimum error in this case. So the algorithm, the gradient descent algorithm, works by varying these parameters so that the error of the line is minimized. And so when we've achieved those optimum parameters, that is known as the trend of this data. And basically, if then from here we can easily tell what would be the predicted house price for a particular square footage. So if somebody asks us what is the expected house price for 4,000 square feet, you just get the value of you can just whatever this equation turns out to be, the values of theta 0 and theta 1, you can put the value of the square foot in for x and find the value of the estimated price of the house. So it's as simple as that. Regression analysis, as far as it goes, it's a very simple technique. So just to mention, this is linear regression, which is a simple technique because the trend is assumed to be a straight line. There are other forms of regression as well, which are a bit more complicated. But anyway, so if you are more interested to learn about, so let's say, what kind of mathematics, what are the mathematical techniques used in machine learning and how are they applied? There is a book which is available for free from this URL. It's published by the Cambridge University Press. So by all means, check that book out. It's very interesting. I'll move on to the project that, sample project that we recently did. Now, this was a feasibility this was a feasibility study. We were working with the local hospital here in Bristol with their CCU CCU, which is what they call the ICU here, the intensive care unit. Here it's called the critical care unit. And what the idea was that the CCU has patients who are often, they might be in a situation where they cannot feed themselves. They might be sedated, or which means that they need external feeding. Or they might, or they might need some special nutrition. So those kinds of patients would need to be seen by a dietitian to to assess their needs. Now, but the problem is that there are so many patients, and their data. So in the hospital, they've got smart beds which collect patient data every few minutes. So things like blood pressure and different hormone levels and all that are collected by the are collected every few minutes for all the patients. But the problem is that, sorry, does somebody want to say something? Okay, so that data is collected for the patients every few minutes. Now the problem is that that data is so much that it's almost impossible for a person to look at that data and decide if which patients need to see dietitians. We wanted some kind of automated algorithm that can help them do that. Okay, so we started by looking at so the hospital had certain guidelines that they used to determine who should see a dietitian, and these variables were taken from those guidelines. So for example, the BMI should be less than this value, and then whether they've suffered in unintentional weight loss over the past 3 to 6 months or things like that. So these were the variables that were in their guidelines that they developed just as a rule of thumb to help the CCU staff decide which patients should see dietitians. So we started with these variables, but we also then got some other variables, standard variables, like looking at whether the patients are receiving oxygen input, whether they're already receiving external feeding or things like that. So the problem was basically just to identify, just come up with, just see if we can develop a machine learning model that will give us good predictions for which patients should see dietitians. So as I mentioned, a machine learning model typically has several common steps. The first would be to clean and prepare the data and manipulate it in different ways. Then we need to train the model, test it, and then improve the model. So are you guys familiar with this visualization? Do you know what this is called? Or what this data is showing? Anybody, has anybody come across this? These are called box plots or box whisker plots. Does anybody know what they're showing? How would you interpret a box whisker plot? Okay. All right. So a box whisker plot, are you familiar with the concept of quantiles? Okay, quantiles are basically when you have a data set and you want to divide it into equal parts, then those parts are called quantiles. Box whisker, a common way is to divide it into 4 parts, and those 4 parts are then called quartiles. So each quartile is 25% of the data set. So a box plot summarizes the quartiles of a data set. So this value is so each of these is a different parameter. So height, weight, weight at admission, ideal weight, prescribed weight, and what the BMI of the patient is. And what this plot is saying is that for the height, that the patient data that we have, the minimum height of any patient is about 140 centimeters. This is the point at which 25% of the patients will have a height below this point, which is about 170 centimeters. This is the median height. So this is 50% of the patients have a height below this, so which is about 180 or whatever this value is. And then this is the 75%. This is the third quartile. Oh, so this is the first quartile, second quartile, first quartile, second quartile, third quartile, and this is the fourth quartile. So this is the 75% value. 75% of patients have a value below this height, which is again 180, I guess, 180 centimeters. And then this is the fourth quartile, which is the 99% percentile. 99% of patients have a value below 200 centimeters. And then these are outliers of the data set. These are data sets that do not fit into, these are data points that do not fit into the distribution. And then these are also the data points that do not fit into the distribution. Similarly, for the weight, the minimum value is about 45 centimeters or whatever, 45 kilograms, or whatever this value is. And then the 25% of the patients are below 60 kilograms approximately. Then half of the patients are below 70 kilograms, and 75% of the patients are below 80 kilograms. And then 99% of the patients are below 130 kilograms, I guess. And then you've got some patients who are outliers, who are not part of the normal part of the distribution, or who are further away from the other data points. Does this make sense? If you've seen a histogram, you can also represent this data as a histogram, and it will show you some similar trends. But this is how you interpret a box plot. Now, what this box plot, when we plotted the data like this, what we learned is that 110 centimeters, or let's say here we have a patient who is 70 centimeters. 70 centimeters is a very, very short patient. If you convert that into feet and inches, that's a very, very short person. And these are adult patients. So this many patients below 140 centimeters, those are really short patients. And then you've got a few patients that are over 200 centimeters. Now, that's a bit, what that kind of tells us is that the data is, there are some problems in the data. Now, those could be, we could genuinely have people who are this short, perhaps, but more likely these are data entry errors. So whoever entered this data made mistakes. So the patients, so these values are sort of errors. Similarly, if you look at the weight, I mean, the minimum weight here is like 45 kilograms, or even less than that. Well, it's not even 45, it's like 30 kilograms for an adult. Now that's kind of ridiculous. So that again tells us that these are probably, there are some errors when entering the data. Similarly, so you've got some people who are over 200 kilograms. Yeah. And because of this, the BMI is calculated from the height and weight. You can see that the value of the BMI ranges from like 30 to over 150. So the BMI, if you ask any doctor, the BMI above like 40 is really, really strange. It's kind of impossible. So this shows us that the data set there are quite a few errors in the data set, and they need to be cleaned. So we basically did some outlier filtering and just removed some erroneous values. And after that, our distributions look like this. So now the height is sort of like between 110 to 220, whatever that is, 200 centimeters. So this is a bit more reasonable distribution. And the BMI is also then similarly, you can see that it's in a more reasonable range. So this was just to give you an idea that one of the big steps that we do in machine learning is to look at the distribution of the data and visualize the data in different ways to understand if there are any problems in the data or any patterns in the data that we should be aware of. By the way, just let me know when my time is up. Much longer do I have? I can quickly go through the rest.
Yes, sir. You can speak for next 10 minutes.
Okay, all right, that's fine. I'll try to leave 5 minutes. I'll try to finish in 5 minutes so I can leave 5 minutes for question answers. So another thing that we do when exploring the data is visualizing the data set and to see if there are any natural clusters in the data, if there are patterns in the data. Now this is done. The thing is, like I said, there are many attributes in the data, many variables. These are only a few of them. We had a lot more. When you want to visualize them, we as humans, we don't understand more than 3 dimensions. So we have to sort of convert the data into high dimensional data sets into the 2 or 3 dimensions. And the way we do that is using dimensionality reduction techniques. So what they do is they identify correlations in the data sets and then combine different of variables together, different distributions together. So UMAP is an algorithm that is one such algorithm that does dimensionality reduction. So using this, what I did was I reduced the dimensions from, I think we had 20 variables to two dimensions, 2-dimensional space, and then visualize the clusters. So you can see that there are some patterns here. There's some separation in the data points here, here, here. So this kind of tells us that there are some natural clusters in the data, which tells us that some kind of there are some patterns in the data that we can look at. Now, then we tried different machine learning algorithms. These are, I won't go into the details of these algorithms, but random forest classifiers, these are decision trees that operate by looking at yes or no decisions. This is a support vector machine classifier. Again, this is using support vector machines, which are mathematical models for high dimensional data, linear discriminant analysis. So what we do is we look at, so the parameter we chose to check their performance is called.
Sorry to interrupt you, that you have next 5 minutes. I just see the schedule. So
yeah,
thank you.
That's fine. So I'll just say, so AUC, again, I won't go into the detail, but AUC is a measure of the performance of a classifier. Machine learning classifier is basically when we want to divide data into different categories. So if we want to say whether a particular data point belongs to a particular category or not, and then we use classification, and AUC is a measure of the classification performance. And the bigger the value, the better the performance. So I'll skip the details later, but yeah, I think we can skip the rest. If there are any questions so far, I'm happy to answer them. By the way, this is my email address for those who wanted to know. You can contact me for any questions.
Sir, I have a question.
Mm-hmm.
Sir, yes. Sir, at what level we can study machine learning?
At any level, you can do it now. There's nothing stopping you. I mean, if you're familiar with some, if you're familiar with these mathematical concepts that I covered, or even a few of them, like I said, I'm not a mathematician, so I know these. I've studied these things, and I know how to do them, but I've never studied them in theoretical depth. But for example, there are many resources out there that you can use to learn about machine learning. Like I had mentioned, that book is available for free. You can download it and read it. And it covers the mathematical concepts as well as tells you how machine learning is applied, how mathematics is applied in machine learning. So you can study them. I mean, we work with the undergraduate students on machine learning projects. So you can do it during your undergraduate, final year or whatever.
Sir, as you have told, it is very interesting subject, but in Pakistan, we don't find any institution which is offering this.
I understand that, but like I said, there are resources on the internet available for you to look at. There are videos on YouTube of people teaching you machine learning techniques. This book is meant to be used for by students to learn machine learning. So there are many resources available. I understand that formal education is not that it's not that pervasive in Pakistan, but informal, you have many opportunities to learn it. So I would encourage you. So one of the, if you don't know, there's something called Kaggle, which is a website that hosts, so they've got different data sets available, public data sets which are meant for machine learning. And you can go there and you can look at, people have applied machine learning to these data sets, and they've put them their code and their techniques online. So you can actually go there and look at what other people have done. You can learn from that. You can even apply your own, try machine learning yourself and apply them on these data sets. So you can get started. So in terms of getting started with machine learning, there are libraries of this. I guess this guy is Pakistani actually. So there are many libraries available for machine learning for which you don't actually need to know the techniques, the in-depth mathematics of techniques. You just need to know how to apply them to the data sets. So you can start with there and then eventually explore into how those techniques in more detail. So there are many ways. Yeah, you can email me for more for more suggestions, and I'm happy to carry this on.
Thank you so much, sir.
Yeah. Can I just ask that if I've put up a questionnaire. It's like for the session, just some feedback from your side, just 3 questions. It will take you 2 minutes to fill it in. Just go to menti.com on anything, your mobile or your on your computer, wherever, and enter this code, and the questions will come up. If you can just go there and spend 2 minutes answering those questions, that would be great. And yeah, by all means, if you have any further questions, email me and I'll respond. Okay.
Thank you, sir. Thank you so much.
Here is my
I'll just put this up again. Yeah, I'll just put this code in the
here is
chat
my
so you.
Question. Sir, can we start data science under the umbrella of mathematics department?
Well, it's a very yeah, and that's a very good question actually, because yes, in fact, within our university, we just recently, like right now, a few days ago, we decided to combine mathematics and computer science into a data science cluster, which I will be a part of. So mathematics is the cornerstone of data science, and yes, you can absolutely start it up there. Ideally, collaboration with the computer science department would be helpful, because there is a lot of overlap.
Because there is.
Yes, go on.
Yes, Dr. Kamar, we can listen you. I think there is a connectivity issue with her, and she is head of department. I want to add that, and we are very much interested, sir, to start some degree or some diploma type degree, because we feel that we are not at this position to start a full-fledged degree, but we just want to initiate these things, or we just want to introduce these things to our students and into our region, and we are looking forward to you to help us in this regard. And also we feel that you are very helpful in this and you are very experienced in this field. And thank you so much, sir, for your precious time and for your knowledge. I know that you are having a very busy schedule, and you just spare your precious time for us, and we are looking forward to you for the further collaboration. And the students will also contact to you via your email, and I will definitely forward my students to you. Thank you so much, sir, for this great opportunity for us.
Thank you.
Thank you. Thank you. Good luck. And here we are having another speaker of the day. She is Miss Vijaya Rahman, and she is doing her PhD from the University of Leeds, United Kingdom, and she is basically an engineer from her academic background, but now she is doing something interesting in mathematics. She having dual degrees. One is from the France and one is from the Belgium, and now she is in the University of Leeds, United Kingdom, and she is a designer, and she is not the designer, cloth designer, she is a ship designer, and it is very interesting, and I find her interest very interesting, and she is doing modeling, and here is her talk for the people who are interested into the modeling and the real life examples of the modeling, and here she is, Miss Vijaya.
Hello everyone. So I will share my screen. Okay. Please let me know if you can see my screen.
Yes, we can
Yes,
see your
ma'am.
screen, Miss Tujia.
Yeah, okay, perfect. So, hello everyone, my name is Wajiha, and today my talk is about the relation of calculus with our real life. Because when I was introduced to this branch of mathematics, I couldn't recognize its applications in real life. And as a result, I thought maybe it's insignificant. And I'm quite sure that many of you, when you learn this calculus, you asked your teacher, like, why are we learning this? When we will use all of these equations? So I always had these questions in my mind, but I kept on proceeding with my educational journey. And as I proceed, I found the significance of these equations and this mathematical field in our real life. And I really, really wish that someone could have explained this to me when I started to learn it. That's why I have chosen this topic. So maybe I can arouse some curiosity in our young mathematicians. I will briefly start with my introduction. So my complete name is Wajiha Rahman, and I have done bachelor's in mechanical engineering from University of Engineering and Technology, Lahore. Then I moved to Europe and I continued my master program as a part of an Erasmus program known as EMship Plus. It's a dual degree master program. So my first master was from University of Liège, Belgium, and it's related to advanced ship design. And then I moved to France to do my second master's from École Centrale de Nantes, France, and it's about marine technology. And currently, I am a PhD student, and I'm working as a Marie Curie early stage researcher at the Department of Mathematics of University of Leeds. So let's get back to our real question. And the question is that, will I ever use all of these daunting equations in my real life? And if yes, then what are the applications of these equations? And where exactly I'm going to use all of these equations? So the answer of this question is calculus is literally everywhere. Its application is also everywhere, from engineering to astronomy to biology to economics, literally everywhere. Because I have an engineering background, so in this presentation, I will show some examples from engineering. So I will show you how we engineers use mathematics to solve some engineering problems. So let's start. No matter which problem you are solving, the first thing is that you need to develop a mathematical model. And to develop this mathematical model, you need to follow some steps. And here these steps are briefly described. It always starts with the observation and research related to our physical problem. And first of all, we do some research, we try to understand the physical phenomena and everything as much as we can understand about that. And then the second step is to make some assumptions. And so we can simplify that complex real life problem into a simple one that can make this phenomena or procedure of mathematical modeling a bit easier. Let's say here I show an example. Let's say you want to make a mathematical model of airflow interacting with the flexible leaf. So one kind of assumption we can make is that, okay, we will not solve our problem in three-dimensional space. We will solve it in just two dimension, like X and then Y, and we will not assume the thickness and other things. Second kind of assumption that we can make is, let's say we are not assuming that the complex shape of our leaf. We say, okay, maybe we can represent it with a beam which is very flexible. Okay, so this is some of the examples of simplifications that we make in our mathematical model, so we can get rid of the complexity, which is actually not very much contributing towards the results. And still with these kind of simplifications, we can get a result which is very close to real life. And then the second step is to use the equations. So if we think about this particular problem, we have a structure here, which is leaf, and then we have a fluid flow, which is air. So we take equations from a branch of physics, which is known as structural mechanics, to solve the problem for our structure model. And then we take some equations from the branch of physics known as fluid dynamics to solve our fluid model. And then we use boundary conditions to link our fluid model with our structure model. So we can say, okay, now the fluid is interacting. Like here, you can say that when fluid interacts with the structure, this structure slightly bends. At first it oscillates and then it bends. And here the red color shows the how velocity of airflow is varying as a result of this motion. Okay, so once we applied the boundary conditions, we have our model linked with each other. The next step is to solve this problem. And we solve this problem in space and in time. Once the problem is solved, we have our results. Sorry? Okay. So once the problem is solved and we have our results, the next step is to validate these results. And this validation is done by comparing our results with the physical problem. So let's get back to our problem again. Imagine, all of you would have observed this phenomena when air it interacts with the leaf. At first, the leaf flutters, it oscillates with air. And if the air becomes steady, then you can see it's oscillating with air. But at a point when the airflow is just steady, it just keeps its position. And if it oscillates again, then the leaf also oscillates in response to that airflow. So in this case, we can see, okay, our mathematical model is behaving quite similar to our physical model. So we can accept this. But sometimes we don't have experimental result or something like this. Or we found that our results are not behaving the way physical problem should be. So what we do, we just keep on repeating this loop. If the result doesn't make sense, we make improvement. We see what is missing, and then we implement that thing, and then we keep on repeating unless we get our results which are quite close to the physical problem. Next, I will show some example from engineering, which is related to ship design. So when we design ships, we have to consider a lot of different factors, which are quite hard to predict in future. Let's say, what if there is a storm in ocean? How my ship is going to behave, because it has a lot of people and they can die if I'm not doing my job correctly. Like here in this picture, you can see this is a very big wave and the ship is just floating and bearing this wave. Or in a case where you have a new design of a ship and you want to know if it is going to work or not. So what we do, again, mathematical modeling or computational fluid dynamics analysis. In this example, I want to show you how it's done. See this ship, it's moving in water, and then you can see how water waves are forming and how velocity of water is changing in X, Y, and Z direction. And these colors are showing how the velocity is varying in different part of this field. Similarly, on this picture, you can see how air is interacting with the structure of the ship and how it will affect the performance of the ship. So this is one of the examples from a transportation sector or from shipping. And that's how we use mathematics to see the future of or the performance of our models. This is something related to my PhD work, and it is related to energy sector. What I'm working right now is that there is a wind turbine, but that wind turbine is not on the land. Instead, it's in ocean, it's floating. And my task is to develop a mathematical model to see how water waves are going to interact with the mast of this wind turbine, and how we can predict the performance of our turbine. So at first we did some experimental tests to observe the physical phenomena. So here you can see this is a wave tank. This part is moving to create waves. And here is the simplified model of our wind turbine, just a mass. We just neglect the rotor at initial stage. And these waves are interacting with the mast. And you can see that it's oscillating. There's a beach to reduce the effect of waves so it will not get back. Now that we have done the observation of our physical phenomena, the next step is to do the mathematical modeling. And here I want to show you how my model is behaving. This model is developed by some researchers in my group and who are my seniors. And you can see that it's also evolving in time. So it's like in 10 seconds, the wave will be like this and it will be moving like this in 11 seconds. And then it's also evolving in space and then in time. And you can see it's also moving in a similar fashion and the way it was moving in our experimental system. So next, I will share a complex example. And in this example, we will try to create a storm in our domain to see how this wind turbine is going to survive. And I think it's like a magic because you can see future from mathematics. Maybe that's why they say that mathematics is the language of universe. So I will just play this video. You can see the time is evolving and there's a big wave and now it's interacting with our wind turbine. And there you see how it's going to behave if there is a big storm in the ocean and your wind turbine is floating. How it's going to behave, how it's going to interact with water. And all of these colors is actually showing how the stresses are evolving in the turbine, how it's moving, if the motion is too much, too less. So we show all of these in the form of these contours over here. So any one of you can guess what kind of equations we are using to simulate this water. So in the next slide, I will share that. This is one of the most famous equations known as Navier-Stokes equation. And at first it looks very horrible and daunting and you might be like, oh my God, what is this? So the trick is whenever you see a complex equation like this, just break it into different parts and then see which part is contributing to which part of our physical problem. So here, rho is the density of the water. So we need to include it because it's a property of our fluid. The second part is how velocity is changing with time. So here, let's say in my example, you can see time, how velocity will change in time, how my wave will evolve in time. The other term is showing how velocity is going to evolve in space. Remember in the ship example, I showed you how water waves are changing in X direction, Y direction, and Z direction. So we need to include this effect, how it's going to change in space. On the other side of equation, we have pressure. So how pressure of the fluid is changing in space. That inverted triangle symbol, it represents gradient and it's about how a value is changing in space. The other thing is gravity. Yes, we need gravity, and because here in our example with turbine, once our wave goes up, we need to tell this wave, okay, once you go up, you need to come down. So this is the effect of gravity that's how we include it in our model. The next step is the viscosity and some non-linear terms in our fluid model. So it shows how the internal stresses of our fluid will vary. So you see how we are doing this mathematical modeling of complex problems and how each and every term in this complex equation is relating with our problem. So I will end my talk with this, and I will say, just keep calm and do calculus. Everything will make sense, and I hope that you will enjoy it once in your life once you understand it. So if any one of you have any questions, then you're welcome to ask me.
Thank you so much, Ms. Vijaya, for your great research, and we really appreciate that you did your best, and it was really helpful talk you delivered to us, and you just increase our interest to the calculus, as we already feel that calculus is very much important, but here you do it something. And anybody from the participants can ask the questions. Panel is here, Dr. Kamran Sumro, Dr. Fiza Zafar, and Mr. Muhammad Hadi Shikaris, and Ms. Vijaya Rahman, all are here. I'm sorry. And you can ask the questions, and Mr. Mr. Muhammad Hadi Shekhar is who will join us after this talk, and he will give talk related to graph theory. But you can ask the questions as we are having some time. We can have this session for 10 minutes, so the participant can ask the questions, and if the panel invite the participants to ask the questions, and please. Here is the panel.
Here is a question. What do you mean by compositional data here? Is it a specific type of data, or we can extend this concept to other type of data also? It's very interesting. First of all, your talk is very interesting, and thank you very much for giving us modeling and such modeling graphical representation of your work. It's really very interesting. In your title, you have mentioned that you are talking about composition. My question is, can it apply to other data which are available in science? For example, climatology. Can we apply it on a data which is related to climate? This is my question. Thank you.
Hello, Ms. Vijaya.
Hello, I think this question is not for me because this is not the title of my talk, compositional data. I think maybe it's from some other, because my topic is computational fluid dynamics and the application of calculus.
Anybody from the panel wants to answer this question? Dr. Fiza Zafar, are you here? I think we should have some break because it was actually the break time, and I hope that you people will join me back at sharp 2:20. And
hello.
Yeah, there is an answer. I feel that here is Muhammad Hadi Shekharis. Sir, you can show your video as well. It is not mandatory, but if you, yeah, thank you, sir, and welcome to the talk, and welcome to the session.
Thank you very much. Thank you for introduction.
Yeah, thank you, please.
Would you please give me the permission to share my screen also?
Yeah, sir, I can. Dr. Saima, Dr. Hadi is actually working with the compositional data, and he is a graph theorist, and we are looking forward for his talk today as well.
Can you see my screen now?
Yes, sir, we can see.
Okay, so I'm from Iran, and because of very tight relation between Iran and Pakistan, and very shared things, a lot of shared things between Iran and Pakistan. I actually feel that I'm not among foreigners, but when I'm among you. And I want to have some words about Maryam Mirzakhani, a brilliant mathematician.
Sir, we
Who
are
was
having some
unfortunately very
problem
short-lived.
regarding to the audio of your talk. Sir, there is some noise. There is some distortion in the line. There is some noise. Can you please
Sorry,
fix this problem?
I have your voice very crystal. Can't you understand my words?
No, yeah, the audio is not crystal. We are facing some noise, or you can say there is a distortion in line. Can you fix this problem? I feel that is a connectivity problem on some internet issue.
Well, let me see. Everywhere is closed, and again I share my screen, but everywhere is working fine for me. I don't know what's the source of this noise. I hope it gets better in time. Okay. So
So there is still there is noise.
I don't know.
Very unfortunate, very
Everything is.
unfortunate that we are having some issue. Please continue. Please continue. It may end at some time.
Okay, I hope I try to speak clearly so that
Yeah.
you can understand me.
Yeah.
Although you have some noises, this is unfortunate. So I want to speak about Maryam mathematician and the only woman to date that awarded the Fields Medal, which is the most prestigious mathematics award, and she had to fight a lot because she had two unforgivable crimes. One of which was she was a woman, and everything is harder for women, and the other is she was Iranian. For example, here I'm Iranian and you are Pakistani, and you just clicked at the Zoom and you joined this meeting. But for me, Zoom forbidden its services from Iranians, so I had to use VPN. Maybe this noise is coming from the VPN I use because I had to change virtually my location to France. Anyhow, I'm going to speak about breaking symmetries of graphs, a subject initiated by renowned mathematician Laszlo Babai many years ago, and he did it for infinite graphs. By 1996, we had another terminology which introduced by Albertson and Collins. They introduced the distinguishing coloring, which is a type of coloring that breaks all the automorphisms, but the trivial one. If you don't know anything about automorphism, don't panic. I will explain later. Here you see a graph P4 and a coloring with two colors, red and black. So this breaks all the automorphisms. This graph has only two automorphisms. One is the identity or the trivial automorphism that keeps every vertex at its place. And the other is to map this red vertex onto this one, and this also to this one, and these two middle vertices onto each other. This coloring breaks this automorphism that I draw for you. This is called the symmetry or automorphism. For C8 and C9, you see another example of distinguishing coloring with two colors. This is interesting because this graph has many automorphisms. In this case, there are 16 automorphisms, and in this case, we have 18 automorphisms, but they break all of them but the identity with a two coloring. Albertson and Collins introduced the distinguishing number as the minimum number of colors required to color vertices of P, so that the coloring only preserved by the trivial automorphism. And a lot of papers published about this distinguishing number and its variations and generalization.
Sorry, sir, I am going to interrupt you. There is much noise behind, and I feel that we should fix this problem, or you should increase the volume.
Okay, let me check if I can increase the volume.
If you can change the connection of internet.
Unfortunately, if I do this, I'm not sure if I can reconnect, or it takes a few minutes. Is it okay?
If it takes few minutes, because your talk is very important to us, and we feel that we should not miss it by the interruption of line or bad connection. So we can have a break, or we can have a question answer session as the participants want, and then you can fix this problem within 10 minutes, and we can join back again at 2:20 if it is okay.
Okay. So I should wait.
Yeah, you can again join us at 2:20, and every participant who are with us, please join us after 10 minutes break, have a good cup of tea, and then came back to us. And we are looking forward to you again. And after these all talks, we will have a panel session of question answer. And if you feel free, feel okay, I'm asking to the panel, then you can have this session, and everybody is free. Every participant is free. Feel free to ask the questions to the panel regarding to their talks and regarding to the topics they mentioned. And thank you so much up to this. And after the 10 minutes, we are coming back again. Thank you so much to everybody. And Mr. Muhammad Hadi, please fix this problem, because this talk is very important.
Thank you, Mrs. Lessams, for this virtual tea, because this is the first time we are having this type of virtual tea. Thank you.
Okay.
Thank you, Dr. Saima. Thank you so much.
15 minutes, we'll see.
Hello and Assalamu alaikum. We are back again. And Mr. Mohammad Hadi, should we start it again?
I'm at your service. I changed my internet provider.
Yes, so
I
let me
think
introduce
it
you
must be
first.
better.
Let me introduce you first. Yes, it is much
Thank you.
better. Yeah, and now Mr. Mohammad Hazi Shikhari is he is a researcher in graph theory, complexity theory, and the quantum mechanics. He got his PhD from Firdausi University, Mashhad, Iran, and he is doing his postdoc fellow at Yazd University. He is a reviewer for the algebraic structures and their applications, Khayyam Journal of Mathematics and Mathematical Reviews. He is also working on the computer scientific fields of estimation for trace of matrix inverse, and he is also working with the distinguishing coloring, especially on the distinguishing threshold and distinguishing polynomials. He is also doing the quantum mechanics with the n-dimensional space, and now he will tell you today about the distinguishing coloring and vertex partitioning, sir, if I am not wrong.
Thank you for your introduction, your beautiful introduction.
Yeah.
I'm very happy to be here among you and among potentially brilliant mathematicians of future. Well, again start from the beginning because I want to emphasize on the strong relation between Iranians and the Pakistani people because we share a lot of cultural and lingual and any other things that we are supposed to be one nation, and the friendship between these two nations has a long history. And also about Maryam Mirza Khani, which should inspire our young girls. And I think that the students of the Women University of Multan have all of them, almost all of them, have the potential to be next Maryam Mirza Khani. By the way, I chose this subject because I think these have the potential for you, for many people to have collaboration with this. This subject initiated by Babai, a renowned mathematician, which is tried to break symmetries of graph by vertex coloring, and he did it for mostly infinite graphs. And in 1996, another terminology for the same subject of symmetry breaking devised by Albertson and Collins, a distinguishing coloring is type of coloring that breaks all the automorphism of a graph, but the trivial one. If you don't know the automorphism, I will shortly describe it for you. In this example, this is P4, and we colored it with two colors, red and black. And it has only two automorphisms. One is that we keep every vertex at its position, which is the trivial automorphism, and the only non-trivial automorphism is that we map this red vertex onto this black vertex, and this black vertex onto this red vertex, and these two middle vertices onto each other. So this coloring obviously breaks this symmetry
Hello. 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 Sir, can you hear the voice of Muhammad Hadi?
No, ma'am.
I think his connection is again interrupted. So we should wait for some minutes. Dear participants, I'm really sorry that Mr. Hadi's connection got interrupted, and as he's facing some connectivity issue, and he's trying to come back to us, I think we should wait for some minutes for him to fix his issue of connectivity, and we can utilize this time if Ms. Vijaya, you are with us.
Yes, I'm here.
Yeah, please. And Dr. Fiza Zafar, if you are here.
Yes, I'm here.
Yeah, please, ma'am. We were having a talk with Dr. Muhammad Hadi Shikharis, but unfortunately he got interrupted by his internet got interrupted, and he is facing some connectivity issue. So we can utilize these minutes. He is fixing his issue, and you can highlight this how the women, because specifically we are focused on the women. As I am also having the background from the Women University, and also there are a lot of ladies today we are having, so you can put the light that how can they get and how can they get the scholarships at the international level, as you both are having this experience. I am also having little experience because I am in UK nowadays. And so we can actually encourage these girls, and you can also highlight these opportunities. Thank you, ma'am Fiza. It is up to you, and ma'am Miss Vijaya.
Thank you, Zilishams. I think the first step that you can take is to identify the opportunities that are specially for you all, not only in Pakistan, also all across the globe. So once you identify, you can target them. For example, if I talk of my postdoctoral fellowship, I did it under the Schlumberger Foundation Faculty for Future program. Unfortunately, this year, according to the indicators of Pakistan, they did not offer this opportunity, but usually they do it every year. So maybe we are also connected with the administration of this foundation, and they were saying maybe next year we again admit the Pakistani students for PhD and postdoctorate, and it is very prestigious, and also it is good in the sense that it offers the maximum amount of grant that anyone can offer you for your higher education. And they are very flexible, very, very flexible. Furthermore, see, you are in somewhere where, oh, okay, you need to compete, but you have to live with your male parts. So you have to train yourself to work with them. So whatever opportunities that are not gender based, see if that you try to find out that if you can handle them, or along with your of course with your responsibilities, family responsibilities that usually women of Pakistan have more as compared to the male counterparts. So you identify the phases of your life where you can spare time to go for them. And for example, I was talking about this Schlumberger Foundation Faculty for Future program. There are many other scholarships like this where the child support is also provided, and so it is good amount that in which you can take your kids with your, if they are not in the later level of their school or their colleges, they are at a level where, of course, they are having the foundation studies, like if they are in playgroups or somewhere, you can take them there. The schooling there is also good. So you just have to manage everything. It's all about the management. It's all about managing whatever you have and whatever you can go for, whatever opportunity you can go for. Then for the mathematics students, I always say that there are some good congresses that happen every 4 years. Maybe most of you will be aware of it. International Congress of Mathematics, International Congress in Industrial and Applied Mathematics. It happens every 4 years, where they most of the time they give you full financial grant, so you can go and travel. So you can just step out for a few days if you cannot put yourself in some opportunity where you cannot take this to a very long time. You cannot engage yourself for a long time. Then you can go for the short-term opportunities. And so,
ma'am, I also, sorry to interrupt you, I also want to ask you a question, that you are now a focal person for STEM at BZU, and for this position, you are having two positions, as an associate professor in CASPAM and having you are a focal person. So we are expecting from you much, because you are playing a vital role in the South Punjab for enhancing or for giving the knowledge of STEM, and I feel that it's very important now for everybody who is studying the engineering or the technology or even the mathematics, and we feel that we are equally important, like the technology and like the engineering. So we are looking forward. I am talking on the behalf of Department of Mathematics, the Women University Multan, that we need some collaboration with the Bahauddin Zikriya University in this regard, because we are not having engineering at this time, at this moment, but we, the mathematics department, wants collaboration or wants training. We need this type of the collaboration that we our girls, our students can have the training from your institute at the level your students are getting that training. And we are looking forward. Please consider this request, and please create the opportunities for us as well, for our students.
Inshallah, surely. Whenever you do something, I think you work for the whole community, you work for the whole region. So it's about extending your hard work. It's all about extending your hard work, your efforts, your work towards for the betterment of your people, of your region, for your country, all around. So inshallah, there's no problem in collaborating. But the problem here is that you need to consistently engage yourself in informal and formal talks, that you have to come around and you need to conversate. What do you want from us? And then we can tell you what we can offer. So, because I am not one individual, it's about teamwork. My department, my director, my seniors, of course, I can work together with the consent as well as with the help of them. If anyone has any question about my talk or anything you want to ask, you can. I feel that Ms. Zile Shams is not here.
Yes, ma'am, I am here. And
Okay.
actually, I was fixing the issue Mr. Hadi is having. Unfortunately, he and I was very excited for this session. And this is very unfortunate that at this moment he is having this internet issue. So it is a curse.
He's in Pakistan or he's Pakistan?
No, he is
or
in Iran. He is in Iran.
In Iran.
Yes. So that's why I was a little bit busy with him to fix this issue. So otherwise, yes, madam, I listen this, and yes, this is very encouraging, and you always encouraged us, as I am your student, and there are lot of faculty members here we are having, and all around Pakistan are your students, and we are very privileged to have you as a mentor, as a colleague, as a teacher, and you are playing so many roles with us at the same time.
You don't have to be too, you're over exaggerating, I think, because all of my energies comes from you all, from all my
No,
students.
ma'am, this is really encouraging.
Madam
And
Saima Zainab, Dr. Kiran Batul, Madam Rafia Bakar, all of you. If I'm not missing someone, Madam Aisha Khakwani.
Yes.
So all of my energies, it comes from you.
Thank you so much, ma'am, for this appreciation. And Ms. Vijaya Rahman, if you like to share your experience, that how you got your scholarship for UK, it will be so beneficial, and it will be give a new enthusiasm to our students to find these type of the opportunities.
Yeah, so I will share my experience, like how I got this idea, like I should do my master's from abroad and not from Pakistan. So, and I will also share some of the preparation that students must do if they want to win a scholarship abroad during their undergraduate. So, first of all, when I was in my undergraduate, most of my teachers, they completed their PhD from UK or from other countries. And that was really motivating for me, that I also wanted to explore other cultures and the way they were teaching. So I started to do some research on internet, like what scholarships are available in engineering or whatever field you are interested. So first step is Google. Just Google it, and then you will know about some universities, some scholarships, and some opportunities that are in your field. And the second step is you must know the requirements, because all of the scholarships, they need some requirements like IELTS exam, some criteria for GPA, some extracurricular activities, or maybe if the scholarship is really, the competition is high, then maybe you require a very good thesis or publication. So these were some factors that I identified during my third year of undergraduate, and I started to work on them. So during my final year, I selected a topic for master thesis that was related to research, and I did a publication in a conference during my undergraduate. And second thing was that I took IELTS and TOEFL exam during that time, so I could meet the language requirements. So first of all, you need to identify which scholarship you want, where you want, and then which documents you need to have to get that kind of scholarship. For GPA, my advice is to keep it around 3.5. It's really good GPA. And normally scholarships, they require something around this GPA requirement. For IELTS, you should have something 6.5. If you can have 7.5, it's better, but try to have 6.5 at least.
Thank you, Ms. Vijaya. These suggestions are really helpful, and Muhammad Hadi again join us, and we are again we should start his talk. And thank you so much in touch with us, remain with us. Thank you.
Well, I'm sorry for the interruption. That was behind my control, of course, but I'm sorry.
Sir, now you have to complete this talk in 15 minutes because Miss Stefanila, yes, the Dr. Stefanila will join us that time.
Yes. So, by the way, Albertson and Collins introduced the distinguishing number, and as the minimum number of colors required to color vertices of a graph, so that the coloring only preserved by the trivial automorphism. And Collins and Train, and independently by Closure and his colleagues, they proved that to distinguishing the color a graph, delta plus 1 colors is enough. Well, what I did for distinguishing coloring is to introduce some other indices, like the number of non-equivalent distinguishing colorings with 1 to k as the set of color, which is shown by the capital phi with my colleagues in Shiraz University, and also the number of non-equivalent k distinguishing coloring with the set of 1 to k as the set of color, which is shown by a lowercase phi. And these two indices are related with this formula. And their distinction is that for the capital phi, we are not required to have k coloring. We might have less number of colors. So we proved that the capital phi of Kn is choosing n from k, and for Pn is half of k to the power n minus k to the power scaling of n over 2. And for the complete bipartite graph Kn, and the capital phi is a half of choosing n from k, and times n choosing n from k minus 1. And the lowercase phi is half of choosing n from k times choosing k minus n from n for the most cases. And we introduced a distinguishing threshold because calculating capital phi and lowercase phi is very hard for general graphs. So, but sometimes it's easier when k is large enough. So we introduced distinguishing threshold, which is shown by theta, is the which is the minimum number of number t, such that for any k bigger than t, any arbitrary coloring of G with k colors is distinguishing. So for most cases, this number is the number of vertices. For example, theta of the complete graphs is the number of vertices, and also for the complete bipartite graph, theta is the number of vertices. But sometimes, for example, at the case of paths, theta is the scaling of n/2 plus 1. And for the cycles, it's a floor of n/2 plus 2. For example, here, if you take a look, we have C8 and C9 and a 5 coloring, which is not distinguishing. So we used 5 distinct colors, but this coloring is not distinguishing because we can have a mapping that maps these two vertices onto each other and these two vertices onto each other. Sorry for not drawing good. And these two onto each other. And the red vertex and the green vertex onto each other. So the lowercase phi and theta are actually connected via this formula, which is phi, the lowercase phi of G is k factorial, the Stirling number of n and k, over the number of automorphisms of G. And again, along with my colleagues at Shiraz University, we proved that, sorry, do you have my voice?
Yes, sir, we can listen to you. Yes, sir. Yes, sir.
Okay, thank you. Thank you. So the only graphs that have distinguishing threshold 2 is K2 and its complement. This is interesting because for distinguishing threshold 1, there are infinitely many graphs. And for 3 and 4 and so on are also infinitely many graphs, which has distinguishing threshold of 2. Threshold of 1 or 3 and so on, but only
Sir,
for 2 there are.
Sorry to interrupt you. We can see you, but we are not able to see the presentation or the slides.
Aha. So again, I try to present. Okay, can you see it now?
Yes, yes.
Okay.
Yes.
So we characterize all the graphs which has theta equals to 3, which are of two types, 1 and 2. And I show it because of the lack of time by examples. Here are the small graphs whose theta is 3. And this graph, which is of order 14, 2 times 7, and 7 is a prime number. And this graph has the distinguishing threshold equals to 3. And there are infinitely many such graphs that has distinguishing threshold equals to 3. And this graph has distinguishing threshold of 4. This graph has automorphism group of Z3. And this graph has the distinguishing threshold of 5. And we can generate a lot of such graphs. So it's not a very easy task, but we are able to do it. For infinite graphs, we proved that if G is an infinite graph, then theta is either 1 or infinity. And again, along with my colleagues in Shiraz University, we calculate theta for graphs in Johnson scheme. And for the most cases, this is the case. With theta is choosing k from n minus choosing k minus 1 from n minus 2 plus 1. And we also calculated distinguishing number of the corona product, which has nothing to do with coronavirus. It's kind of graph product. So we proved that the distinguishing number of the corona product is the minimum of k, so that the capital phi of h is bigger than the d of g over k. And theta of the corona product is this expression if H has some non-trivial automorphism, and if H is an asymmetric graph, then theta of the corona product is this expression. For lexicographic product, Ali Khani and Soltani derived some bounds on lexicographic powers and lexicographic product, these two bounds. And we proved that we can exactly calculate in the terms of phi so that the distinguishing number of lexicographic product is k, where k is the least integer that the capital phi of y is bigger than the distinguishing number of x. And for the theta, in another paper with my colleagues in Shiraz University and Yazd University, I proved that theta of the lexicographic product of G and H is this expression. Sorry, I don't read this expression for you because of lack of time. And whenever this H is an asymmetric graph, and if H is not an asymmetric graph, then the lexicographic product, the distinguishing threshold of the lexicographic product is this expression, which is easily calculated. And about the Cartesian product, which is a bit harder because the type of automorphism we have for the Cartesian product is more complex than other graph products. We calculated the theta as the maximum of theta of gi minus 1 times the quotient, the size of the quotient graph, which is if I, for example, is 1, is the multiplication of the size of these graphs. So and we should add 1 to receive theta of g. And when we have powers of the Cartesian product, then the expression changed to this one, which is again easily calculated by a computer. So we can easily now calculate any Cartesian product, which is in general case. So I'm actually thank you for listening to my talk, and I'm sorry because of the internet problem we had, but I had a lot of other things to say. One of them was that we can work on it because this problem seems a little complex, but it's not as complex as it seems. So if you know about automorphism, you can enter this kind of problems, and this is interesting problems that has values that praised by the mathematical community. So it would be good if you want to enter mathematical researches. This is a good subject. I'm at your service if you have any questions. I think I finished on time.
Yeah, thank you so much, sir. And it was really an interesting talk, and we both can feel sorry for the interruption of internet, but we fully understand that this is really a demanding topic and need so many researchers to do the work on this topic. And I'm really thankful for your precious time and your research ideas you shared with us. And please stay here, and we are having another speaker as I can see her. And let me introduce the speaker of the day.
Thank you for having me.
Yeah, thank you, sir. And let me introduce Miss Stefanila Bauta, if I'm not wrong pronouncing her name. And ma'am, very welcome, very welcome. And I know that it is very difficult to manage because we are having the time difference of 8 hours. And we are very blessed to have you in this session, in this one-day international webinar on the challenges, innovations, and opportunities in mathematics. And I am Zile Shams, and here we are having Miss Stefanila Bauta, and let me introduce her that there is a big introduction, but I am just going to focus on the main parts of her things, the great things she have did in her life. She is graduate in theoretical physics at the University of Bologna, Italy, and PhD in mathematical physics at the University of Chicago, and the research assistant at the Ecole Polytechnique, and she is the associate member of the group of astronomy and the dynamical systems, and the postdoc at the Fields Institute, McMaster University, Canada. And she is also a visiting scientist of the various academic institutions like the Tata Institute in Bangalore, University of Barcelona, CRM Belletra, and Ecule, and there are some institutes from the Spain, even I can't pronounce them well, and sorry for this. And she is Moscow Institute of Physics and Technology, and she is also working as the adjoined professor. She is associate professor, and she is working here in the Federal University of Rio de Janeiro, Brazil. And likewise, Ms. Fatma Ertel is also here, ma'am, with you. Okay, let me introduce her. This is very interesting talk, and we are very excited actually to see you here. And this is a joint talk. Actually, I want to highlight this thing. This is that Miss Stefanila and Miss Fatma Ertel are going to have this joint talk. And let me introduce Miss Fatma Ertel. Miss Fatma is actually graduated in physical therapy at the Federal University of Rio de Janeiro, MSc in biological sciences, and has a position at the adjunct professor at the Federal University of Rio de Janeiro, and she is member of the directory board of the Brazilian chapter of Organization for Women in Science for the Developing World, and this is amazing, and the committee of the diversity of the Brazilian Society of Neuroscience and Behavior, and main topic of the interest are the behavioral neuroscience, defensive reactions, neuroimaging, brain, and the diversity in science, and lot of more. Thank you so much, and thank you for Miss Fatma, if she is with you, and this is your time now. Thank you.
Thank you. I will share from the iPad. Thank you so much for having me here. It's a great honor. It's the first time in Pakistan.
Yeah.
And so we're very pleased and honored that you let us meet you. And we hope there will be other meeting and our other interaction. So I will share my iPad. So let's see if I can manage to do that. Screen start.
Let me know if you can share your screen, or
yes. Yes. Okay, so so I'm part of the federal. I'm in the applied math department that is part of the Mathematical Institute of the Federal University of Rio de Janeiro. And so since it's the first time, we thought to tell you a little bit about our university. It's in Rio de Janeiro, so you might know that it's a beautiful city. And our university is one of the oldest one in Brazil. It was founded in 1920, but it was a collection of institutions that had a much older history, like, for example, the Escola Politecnica, the Polytechnical School, that was founded already in 1792. and other the faculty, the law school that was at the end of the 19th century, and the art school. So it's a big university. It's about 60,000 students. And we have a campus where we are, Fatima and I, we are in the campus that is called the island of Fundão, that is, beside the department and the center. We have also technological park where there are host some of the firm, and there are interaction with some of the team at the university, of applied team at the university. And the Mathematical Institute, where I belong, it's a rather international institute. We have 23 nationality, and in fact, it's I think it's quite tough. Okay, if you can see, we are even we have a colleague from India. And we have 3 Iranian colleagues. We don't have any Pakistan so far, but they're very welcome. And we even a colleague.
So we will be definitely be in your collaboration now, and you will having so many friends from Pakistan now.
Yes.
And we are looking forward to you, hopefully.
Yes, you can see that we have like a woman from Iran. She's an excellent, it's from algebra. Maral, she's an excellent teacher, colleague. The student love her course. She gave a great course on group theory and so on. And then we have even someone from Taiwan. So we have 4 from Asia. And I want to outline that among the Brazilian colleagues, we do have a woman that stands out, that is Maria Eulalia Vares, that was an editor-in-chief of the Annals of Probability during 3 years. So women are very strong in our university. And our institute also our faculty have studied in the 5 continents. You know, we have a very diversified culture and mathematical culture, and also the Mathematical Institute and the Computer Science Institute, they are very diversified as a research area. So I mean, so this will be something to explore, a common research ground. But now let's talk about women in science. So in 2000, so we are talking about 21 years ago, I was asked to give, was a year of the women in the science, in the math. So I was asked to search for some numbers. And at the time, people were talking about women in the science and so on, but not as much as today. So I found a very interesting website that was the International Astronomical Union. It's interesting because it's a union. Usually you have for math at least, you have the Union of Brazil, the Union of Italy, the Union of America, but the astronomers have an international union. So it's good to have some general overview. And so in particular, they have a gender distribution for by country. And that's very interesting because you can see, for example, here, they have the percentage of women and men by age over the whole, for whole country. And so already you see some interesting facts that if the percentage of the women, you know, they start roughly, you know, 40% here when they're 20, 30 years old, then as the age increase, you see that the women percentage in this association decrease, while the men increase. And so then it's very interesting to go by country And you can ask yourself if there are some cultural bias, but these things get very interesting. At least for me, I'm Italian in origin, and in Europe you always have this idea and so on that Southern European countries are more are discriminating more towards women, while the North European country are more equal. But then when you see here the percentage of women in Latino country, you see that the women are in red, they're higher with respect to North of Europe here, that they present generally a lower percentage. And the other curious things is that was to consider English-speaking Anglo country. Anglo country like Canada, US, UK, they overall, they are kind of the same, they share the same, and these are data of 2021. They share more or less the same percentage. In 2000, this was interesting, in 2000, the percentage were much lower. They were about here. So they did improve with respect to 20 years ago. they almost doubled. But I want to say that also 20 years ago, this country were about here. So they were still, the Latino country has their call. They show somehow more the present, and this is we can see also in the math or in other scientific area, they show more the presence of more women, But of course, this might reflect also some other parameter, like how much is its value in each country that particular job. But if we look for some other, if we compare the country, for example, of Asia, also we see some curious things that will be interesting to understand, because we see that, for example, here, the percentage of Thailand, Turkey, Ukraine, it's higher than the others, okay? But still, if you see, some countries, they're still, they are the same as basically Canada, US, or Finland. So, but this is much higher. It's 33 than the others. So why? This would be very interesting to see. About how to promote women, there have been in the math world recently this idea to have a journal where, because I mean, there is this idea, the peer review, the referees, who is refereeing the work. And so the American Women Mathematical Society, the association, they create a new journal where women are encouraged to publish. That could be an idea. But then there are other ideas, because each of us can contribute, each individual can contribute to the community in a different way, because each of us, actually women or men, are different. And what about collaborative versus competitive approach? So why maybe we don't rethink the way about science and the way about science is valued. So in particular, I want to stress a very interesting, I want to stress this person, Laure Saint-Ramond. She's a great mathematician. And just if you look at her CV, she will put this on the top, born the 4th of August, 1975, married, a mother of 6 children, okay? And this woman, she's an analyst. She was a professor at 26 years old with 2 children. And she was elected member of the French Academy of Science in 2013 with 6 children. and she was shortlisted in 2014 for the field medal. She was very close to get it. And on top, she's also a cello player, and she does concert for even in hospital. She does concert for she gives her time to music for the others. So this amazing woman, of course, how this is possible. This is might not be the standard way, especially with mother of 6 children. Of course, it's possible because the background, the family is her father was already a mathematician, so there is a value to study math. Her husband is also a scientist, and there is a sharing in the house. She lives in a country, in a place where there are kindergartens, so her kids, 6 kids, can benefit from the school system. And she has family also supporting, the parents, her husband's parents. So she has all the support where she can do very well her job. And even her advisor, she used to say that whenever she was pregnant, a beautiful paper will come out, not just a new son. So women in good condition, even mother can be great scientists, and be motherhood should not be a problem. So on top of that, Laure, on 29 of May 2018, gave a great inspiring talk. And well, I can send you the link. I put the link, I don't know why it's not appearing. But this talk at the French Academy of Science, the title was The Science That I Dream of, La science dont je rêve. And what did she say? What were the outline of this talk? And that I think we should all, think about. She said that alone we go faster, but together we go further. Seul on va plus vite, ensemble on va plus loin. And this is so true, when we learn from each other, from the group effort, when the individual is not the main focus, but the group activity, we can benefit from each other so much. And she stressed the fact that we should value more collaboration than competition. And this should reflect also the prize that, for example, in math, that we give, they should give to group instead of individual, instead to favor some kind of personality that is more individualistic, to favor this more cooperative in the science. And I think that women, they are usually raised to be multitask. They're usually, in general, of course, we're all different, but in general, they share this community thought more. And in France, she's not the only one. In fact, she collaborated with Isabelle Gallagher. Isabelle Gallagher also, she has 3 children, not 6, but 3. And she was professor already at 31 years old. She is also a very extremely excellent career. She was junior member of the Institut Universitaire de France in 2009. She was one of the invited speaker of the International Mathematical Conference at Seoul in 2014. She got silver medal for CNRS, and so on, so on. And she's now, since 2018, the director of the Department of Applied Math at École Normale Supérieure. So, of course, she must be excellent to get this position. And again, she's a mother. So, collaborative research. So here comes a little bit to talk about my research, because of course, being in a highly interdisciplinary area, I have to collaborate. I have to reach out. In fact, what I work just to two words. I work, for example, here we see the surface here of Jupiter. And here there are some formation of some tornado. So we are interested in understanding how this formation of tornado get this shape, why they stay where they are. So the movement, the dynamic of tornado on surfaces and on masses, even in general. And we study, for example, what about if our surface has some topological property? So for example, here masses moving, interacting, gravitational masses on the top of the cylinder, how the topology of the cylinder affect the dynamics. So this is in the area of mathematical physics. And you see, to tackle this problem, I have to talk to topology, differential geometry, I have to do dynamical system, and I have also to talk to people, for example, to do atmospheric dynamics. So it's very interesting to be connected to all these different people. On the other hand, I also work on mathematical modeling of epidemics that, of course, nowadays is sadly very much on the news. And here you have other kind of mathematics, because here, for example, this is Italy. If you want to understand how these are the different regions of Italy, we have 22 regions. And then this line now are the train track, how the different region, they kind of, it's a very schematic way to represent how the different regions are connected. And so now to study this kind of problem, now we're going to work using a complex network and dynamical system and control theory and so on. So when you work in such an apply a modeling environment, when you have to deal with observation and modeling, and then to study mathematically the model that you obtain, you have to deal with a lot of different kind of background. You need a lot of mathematical tools, and for this, when, for example, they ask me, what is your research area? I cannot spot one research area. For me, math is all connected. And so in interdisciplinary work, we do benefit from this connection with many people. We have to connect with many people. And sometimes when you talk to, in the mathematical framework, this is still something not very well received sometimes, because they ask you where you belong. And for me, I belong to math or belong to science. It's very hard. But I think that this is another way of training the brain, because you have to be able to talk to different people in different area, and this is very good gymnastic for your brain, and sometimes it open up horizon for actually even new kind of math. Okay, so still about collaborative. So, okay, collaborative is naturally in international, in research, when you do research in interdisciplinary area. But now, what about the way we teach and the way we evaluate our students? How the student can get this? And pandemic, like we see now, has forced us to discover some alternative ways of cooperation through collaborative online courses. And we experiment one of these last year, at the beginning of last year, and we had a course on challenge on biomathematical modeling. And this, we were very lucky because we could bridge students, mostly in Brazil. The green are the student, but the teacher, the professor participate to this course could be everywhere. And so we even have someone from Andrew Francis from Australia, an algebraist, working on some genomic problem. We have people from the States, we have from Belgium, we have from France. And so this is a new opportunity to collaborate, and the student can benefit from good professor everywhere. But then, and this year, the students were evaluated on project, so on group projects, so the student had to work together and present their project at the end of the course. But then now, within the Magalhães network, it came out this more on the engineering side. They came out with the idea to use also these online collaborative courses to help the development of some villages. They needed to improve their energy and their water situation. And this came out very interesting, the way they colleague, because it is the work of my colleague in the Magalhães network, mostly from Chile, University of Chile and University of Andes in Colombia. They come out with this very interesting way of evaluating the student. The student is evaluated 30% on their individual performance and 50% on their team performance and 20% on their intra-team performance. Because of course, if the team works with the water, the other works with the energy, they have to work well together. So I think that thinking in this way, giving to our students, passing to our students a message more of cooperation instead of individuality, will help to have a better scientific work, and maybe also a more productive, for sure, a more productive work.
Ms. Stefanila, thank you so much, and sorry to interrupt you. And this is thank you. Okay, and you are done. And we were actually facing this, and now this is time for Ms. Fatima. And before that Ms. Fatma start to give us her talk, I want to pay my thanks to Ms. Stefanila, and she is really very good. And it was I'm really feeling sorry for this, that this is so little time we give to you. You need we actually need a day, at least a day, to talk with you on these opportunities and the cases you highlighted and the women you highlighted in your talk. These are really remarkable, and we will surely have some separate session on this again. This is your first introduction to Pakistan, and welcome to Pakistan.
Thank you, thank you.
And now this is Ms. Fatma.
Thank you.
Yes.
Thank you, Dr. Stefanila. It was a very valuable, informative talk. And I was really surprised to know about the women all around the world, which you have explained with us, told with us, introduced with us. I was really surprised. Thank you. They are very dynamic ladies, no doubt.
And I sorry to interrupt you, Ms. Fatma. Again, I want to add this. She was Dr. Kamar Ubab, and she is the head of department here in the Department of Mathematics. And we are looking forward to you, Ms. Stefanila and Ms. Fatma, after this talk, that we will again have beautiful sessions with you. Thank you. And this is Ms. Fatma's time.
Okay, thank you. Can you see my screen?
Yeah, we can see. I can see if all the participants can see.
Okay, thank you. It's a great opportunity for me to talk to you in Pakistan, and I would like to thank all of you and also Stefanella for inviting me. Well, I'm a neuroscientist, and as a neuroscientist, I'm interested in functional brain imaging. I study people who have gone through trauma, and our main interest is to investigate the brain reactivity that differentiates people that recover from trauma, and also those that develop a psychiatric condition named post-traumatic stress disorder. And this is my main interest in research, but as a neuroscientist, I faced many data and situations in which it was very clear that women are underrepresented in science in the most prestigious positions, at least. And I'll talk to you about some of the actions we have taken to increase diversity in science. This is a graph of a study developed in Brazil that shows the scissors effect. And this is an effect that appears in all scientific societies and all around the world, but this is a graph that represents the Brazilian research. And here you have all the fields of research, and it shows that in the first stages of the scientific career, you have 57% of women as undergraduate students. And as you go further to positions of more power and like the Minister of Education, the President of the Brazilian Academics of Science, the percentage of women falls and reaches 0%, and the percentage of men increases. So this is called the scissor effect. And you can see that there is an underrepresentation as women go further in the field and in the profession. And Stefanella showed some detail about this also in other fields. And this is a multi-factor problem. And we tried to address this by searching some aspects related to that. And one aspect is the underrepresentation. Oh, I don't know if you can see here. Well, it's the underrepresentation of women in scientific meetings. And this is one representative paper that shows the underrepresentation of women as speakers in the 2011 meeting of the Society of Evolutionary Biology. And I have to advise you that this is a women-rich society. And this is just representative, but you can see that in many scientific societies, in many fields of research. So you can see here that the percentage of women, when you consider the posters, are around 50%. And when you look at regular talks, the percentage of women speakers falls to 40%. And invited talks and plenary talks that are the most important talks in scientific meetings, the percentage of women speakers falls to 20%. So as the importance of the talks increases, there is a reduction in the percentage of women speakers. And what is the problem with that? Well, the authors discuss that, and they said that women have fewer venues to present their research. They have less opportunity to increase their professional network and smaller chances of promotion and financial support. You need to consider that between the audience, certainly there are people that are going to evaluate the research of this person. And if you show your research, you have an increased chance to have financial support, for example. And another big problem is that the paucity of women speakers also sends a message to aspiring young female researchers that there is no room for them at the top. So if you look just at white men presenting their work, the young aspiring female researchers will think that there is no room for women at the top. So we try to address this by researching our scientific society, that is the Brazilian Society of Neuroscience and Behavior. And what we observed is that we are a women-rich society. If you look at all the members, we are 62% of the members. And if you look just to senior members, we are 57.5%. And then we consider, as senior members, we consider just researchers. And well, we consider this as our reference. That should be the percentage of women speakers at the most prestigious presentations of this scientific society. But this is not what happens. If you look at full conferences, you can see that from 2010 until 2019, that the percentage of women rises to, down to 0 in 2019, and it's far below the percentage, the reference value of 57% that is here drawn in this dotted line. And if you look at the mean, the speakers, women speakers, are just around 20% of the full conferences. That is the most important conference that happens in the meetings. And when you look at symposia, you can see that we are also very below, far from our reference percentage of speakers. It has a tendency to increase, but it's still down and it's around 40%. But another thing we thought that was interesting is to look further to symposia, because in symposia you have one chair and the chair invites speakers. So we looked at the gender of the symposia chair, and we saw that you have 40% of female as symposia chairs and 60% of male. In the male chaired symposia, you have only 26% of female speakers. And when you look at the female chaired symposia, you have 59.5%. And this value reaches close to the expected value of 57%. If you compare this percentage with this percentage, you have a statistical difference. So these results are being published at the Brazilian Journal of Medical and Biological Research. And it's an important thing because one of the suggestions that we find that it's important to reach a higher society with higher diversity is to investigate the composition of the society and to divulge these results. And as a result of this approach, we now have the diversity committee in the society. I'm part of this committee, and we are trying to have further information about the composition of our society, and we are developing policies to increase diversity in our meetings. Well, another approach we made was to study the social implicit bias. This is a paper we are now publishing in the Frontiers of Psychology, and we are trying to face racism and sexism in science by fighting social implicit bias. This is a paper written by Latin and Black women in science. And our group is studying this for some time. And to talk about this paper, I'll talk a little about implicit bias. I don't know if you are familiar with this concept. Well, implicit bias refers to the attitudes or stereotypes that affect our understanding, our actions, and our decisions in an unconscious manner. These biases, which encompass both favorable and unfavorable assessments, are activated involuntarily and without an individual's awareness of intentional control. So our brain has the capacity to automatize many processing, and it confers to us a great advantage. Imagine if you had to take a conscious decision for every action that you have in the world. It would take a long time, and it would certainly be very costly. So we automatize many of the decisions based on our history and in the context we are in, and it gives us some advantage. So, but the thing is that if you grow up in a society that has prejudice against some social groups, this is going to influence your actions and your perceptions and your interaction with these social groups. For example, in Brazil, we had like 500 years of slavery, and this creates a prejudice against Black people. So people automatically and unconsciously attribute some characteristics to groups marginalized like Black people or women or so on and so forth. And it interferes with many aspects of, since the age of 6-7 years, we have manifestations of this implicit bias, but I'll show you here some aspects of that in the scientific career. So this paper shows that you have an implicit bias that women are not so capable to science. And this is an implicit bias. It's not something that is serious, we know that, but the authors studied implicit bias in science by doing the following. They prepared a fictitious curriculum, and they sent this curriculum to 127 researchers in United States, both men and women, and asked the researchers to evaluate the curriculum. Half the participants received the curriculum with the name of a woman, and the other half with the name of a man. And they asked them to rate the curriculum. And what they saw is that the same curriculum was evaluated differently depending on the name written on that. So for competence and hireability, you can see that when the curriculum had the name of a man, it has a higher rate than the curriculum with the name of a woman. This is an implicit bias that is created by our experience in the world that creates the wrong idea that women are not so capable than men. And what is more amazing is that the salary the researchers were willing to pay to the candidate was hugely different depending on the name of that was put on the curriculum. Another aspect that is very important is the referees of the journals that receive our proposal of articles to be published in the journals. So here the authors investigated in the Behavioral Ecology journal what happens after you start the double-blind review. In double-blind review, nor the authors or the referees know the gender of each other. So they observed that when you compare after the double-blind review and before, you can see that there is an increase in the percentage of papers published by women as compared to beforehand. And you have a decrease in the percentage of the papers published by men, showing that even when the referees evaluate our research, they are influenced by implicit bias. Then that's what we talk about in this paper. I hope you access that, and it's very interesting. And at the end of the paper, we have some recommendations of some actions to be taken by editors and reviewers of scientific journals, to members of selection committees, and to people in positions of power in funding agencies and research institutions. And I'll show that just to give you a flavor of that, considering this is a research institution. Well, you have to have maternity support policies, diversity policies, and try to respect and value different views of the world and experiences of people from negatively stereotyped groups. Well, we have many suggestions. I hope you assess that in our paper. And another result of our actions was the institution of the Brazilian national chapter of the Organization for Women in Science for the Developing World. And I'm part of the directory board together with Sumbal Sari, Danila Dias, and Eliane Volchan. This is the link to join OWSD. And I'm happy to tell you that through this link, you can also be a member of the Pakistan national chapter of OWSD. So you have also in Pakistan this organization that is a very nice initiative to increase diversity in terms of gender. And another action I think it's very important is to be a member of this repository data in which you have the name of researchers in many different areas of research. Why is this important? Because when you look for someone to talk about a specific topic and you don't know anybody who works with that, you can search on these lists and you can invite more women to talk and to give them more opportunity to show their research. Well, and why is this important? Because gender diversity leads to better science. When you have a team that has diversity, not only in terms of gender, but also in terms of race and social background, so on and so forth, you have the more capacity to create more different ideas and to answer important questions. So diversity in science can promote new discoveries as it expands the points of view, issues, and areas addressed by researchers. So it's also gives more profit, and there are many papers that show that. Well, I would like to thank you for hearing me, and I hope that I did not take too long.
Yes, thank you so much. And I really appreciate your work. And it is actually the need of time that that we should be focused on these parameters as well. We should know that how can we progress in the science, because science needs us and we need science. And I also want to introduce some speakers are with us. It was a session, and we started it at 11 o'clock in Pakistan, as you know, and you are the last speakers. You both are the last speakers, but luckily, and we are having Dr. Fiza Zafar with us, Dr. Muhammad Hadi Shikharis. Dr. Fiza Zafar is from Pakistan, and she is also a renowned mathematician, as well as she is doing for STEM, and she is enhancing her interest to the STEM. He is the focal person of STEM in Bahauddin Zikri University, which is one of the biggest university in our region. And as well as we are having Miss Wajiha Rahman. She is also a PhD researcher, but she is doing something like the applications in mathematics. And Muhammad Hadi is with us, and he is doing the research, and he is the reviewer of the editorial board, and he is a reviewer of journal in Iran. And Dr. Fiza Zafar, if you can hear us, please.
Yeah, thank you so much, Zilla Shams, and pleasure attending this session with Dr. Stefanilia and Dr. Fatima, and it was very, very enlightening talk, and you have rightly, I think, give the awareness to the women of science and mathematics of Pakistan about the implicit the problems that we face at the social level, the walls that we have, the stereotypes that we have in our societies. But of course, it's about competing either with your male counterparts, and it's about making progress and excelling further in any possible way.
Thank you so much, Dr. Fiza, and to Miss Fatima, and as well as the Miss Stefnila. If Miss Stefnila is here, if I can see her.
Yes, I'm here.
Yeah, and the Dr. Fiza is also here, and the girls, the most important part of the session, the students are here, and there are some other researchers like the Miss Wajiha and Miss Humaira is here. Miss Humaira, I want to introduce Miss Humaira. Miss Humaira is from Hungary. She is doing her postdoc. She is doing her research in graph theory, but she go through with the competition, and she is woman in science. I am woman in science. Dr. Fiza is woman in science, and everybody here is in science, and we need each other for the collaboration. So this is now an open session. Everybody who is not having any noise behind his or him can open their mic and can ask the questions. If the panel wants to take the questions and to answer them. This is a free session to make your opportunities, to see how you can go through with the science, how you can cope up with your problems, because I feel that everybody is having some stress. Is the social stress, or it is the stress related to the science, or it is the stress related to the community, but we are all facing and we are all solver. I strongly believe that we can solve it, and we can actually make the ways for each other. So now the screen is yours. Screen is for every girl here. So if anybody want to ask the questions, this is an open session.
Hello, ma'am. Excuse me. I'm
Yeah.
Zahid Abbas from
Zahid, we can listen to you.
I have just completed my BS Mathematics and I'm looking for some research. But as a beginner, what you suggest for me and for all those students who have just completed their MSc or BS Mathematics?
Yeah, there are so many people here to answer you this question. So who would like to answer this question?
पानी है पहले इसमें पानी है.
Yes. Anybody wants to?
He was talking about research, not by associating himself to any further degree. Are you pursuing some higher degree, or you have just finished and you're looking for some opportunities?
Ma'am, I have just completed my BS Mathematics and I'm looking for some opportunity for some institute which can offer me any research or like in MPhil or PhD, because I belong to a very small city, Vihadi, and it does not offer anything.
Oh, right. In Pakistan, if we see in Upper Punjab at LUMS and at NUST, I see many opportunities like research assistants and research fellows. Maybe you can go for them because it is the first way to enter in again in the higher education institute and go for the possible opportunities that come for you. It will also help you to identify, because when you will link up with some, of course, faculty of the university, of course, you will be offered with many other opportunities after. So I feel that it's one way to move further.
Okay, ma'am. Thank you so much for your answer. Thank you.
And I also want to introduce that Dr. Saima Akram just joined us, and she is also a very renowned mathematician here in Pakistan. She is an assistant professor in Bahauddin Zikri University, which is one of the famous university in our region. And there are other universities as well, but the Bahauddin Zikri University is playing very vital role in educating a part of gender, but the women universities fully focused on the education of women, but we are collaborating with each other, and actually we are the students of Bahauddin Zikri University. The lot of the faculty members are students, and here is Miss Saima Akram, and if anybody want to ask the question, you people are free to ask the question or discuss the opportunities or discuss your research interest. And even if the panel want to advise or suggest anything, you are warm welcome.
Thank you very much, Ms. Elisham, for your nice introduction. I'm very pleased to hear Madam Stefnella, about women who successfully made contributions to science, and they got the professorship in their early ages, like in 31, 33, with 2 or 3 children. And I conclude that you cannot be stopped by these taboos like having children or having family stopping your career. But if you have encouragement inside you, you should go further and further. Nothing can stop you. And I appreciate the organizers of this conference. Continuously hearing I cannot leave this. I'm not leaving this conference even for a single minute. My video is off, but I am joining all of you because I don't want to these basics of knowledge that we got in this short time. And I hope that the speakers that you have invited today, we have a chance to collaborate with all of these such wonderful female mathematicians. And I appreciate the organization, the Vice Chancellor of Women University, and all the organizers and all the speakers who are the real asset of this conference. And they have delivered the excellent talks in a very short time. And my heartiest congratulations to all of the organizers and speakers. And
Thank you
secondly,
so
I
much.
must, yes, I must advise to all the young researchers, please pay your part, do your part, even at the small level, and explore what you can do next in terms of applications. You should apply mathematics in your real life, and you should free your mind for thinking and questioning, because if you questioned, you have new horizons and new ways of doing the same thing. Thank you very much.
Thank you so much. And she was Dr. Saima Akram, and likewise there are other renowned mathematicians. There are other girls who are trying to do research in mathematics. We are having the diversity. We are having the different research areas. We focus on the applied mathematics as well as we go for the theoretical mathematics. And actually, we Pakistanis are searching for the good opportunities because we are having so much potential, and this is the right time that we should understand that we have to do something with science, and we are here with Miss Stephnila and with your advices and suggestions.
Nazil, I would like to say something, please.
Yes, please. Yes, please.
I, Dr. Kamar Rubab, as a chairperson of Department of Mathematics, I really very thankful to all of my speakers of today. These are very important talks, but time was very less.
Yes.
It was not the sufficient time for their these legends, really legends. These, and I would like to thank Madam Stephnila, and I would like to say that please guide our student about studies in abroad, especially the girls go abroad, but they face many problems. How they will overcome these problems and how they can manage these things. Please.
Can I say we,
Madam Stephnila, please.
Yes, I'm happen to be also the director of international relations in our institute. And so what we are seeking some way of to have a double title to affiliate our university to other university, so the we can share student with other university, so our student can work with a professor abroad, or your student could be working with us. So of course in pandemic time, this in person is more difficult, and also sometime in this moment Brazil doesn't have a lot of financial support, but we can foresee this kind of exchanges. So this kind of double diploma or exchange student, the student pass some time here, or our student pass some time there. This is something that we can try to work on to facilitate the students this exchange between institutions.
Thank you so much, and we really need it. And if there is any other question from participants.
Assalamualaikum.
Yes.
Assalamualaikum. I'm Hafsa Maheen from Women University. Thanks to Dr. Kamar and Dr. Zilisham for such a wonderful opportunity to have with such great speakers. We are facing so many problems especially when we are taking classes of BSc or MSc, because if I talk about myself, my first 3 classes are just on about all the things about sets. What is the difference between arithmetic, algebra, geometry, trigonometry, and all the basic things. So it is my question also, what should we do on ground levels, on school levels, to make these things clear to the students, so we should avoid these very basic topics and these basic concepts. Like students even don't know at MSc level or BSc level about these very basic topics. So I think we should do a lot of work, and there is so much space to do the work on ground levels, so that we avoid these type of difficulties.
Well, I think that I can talk a little about that. Some things we are trying to address here in Brazil is to go to the schools and to discuss the implicit bias and other kinds of gender stereotypes in the school, the public schools in Rio de Janeiro. And we found some interesting evidence that shows that if you develop a science project with the children and you have examples of well-succeeded women in science, it starts to grow the idea that there is room for women in mathematics. And well, I think today I have a 13-year-old child, a girl, and it's very interesting because I love mathematics, but her teacher, he also creates some idea that women are not good to mathematics. And you need to do that, an effort every day to build the idea that yes, women are built to mathematics and all fields that they are interested in. So I believe that we need to have access to the university. We are bringing the students from the university to the schools to talk to the children and to stimulate them to join the university and to say that there is room for everybody everywhere. In Brazil now we have the quotas for people who are Black or studied in public schools or have a low income. And this has increased the quality of the university. And I think that we should have this kind of support and also financial support to keep those students in the university, because it's not just to be sure that they are going to enter the university, but also that they are going to remain on there and having financial support and other forms of support. I think there are many actions we need to do, and we need to go to the schools and try to work together to build this idea that there is room for everybody in the university and in every field of research.
Exactly. Thank you so much, Ma'am Fatima, to answer my question.
Thank you so much. And it is really a nice discussion. If the panel have much time, can we take another question?
Yeah, sure. We can take one last question, maybe.
Yeah, the last question and very compact question and the mostly asked question.
Can I just comment one more thing?
Yeah,
human being is a social being, so needs to feel that it belongs to a community. So it's very important to strengthen what Fatima said, that there is a science community for a woman, that she's not external, but she's something that she can belong. So it's important that what you're doing now to create more discussion, some women circle, but it could be only just not women, could be whatever minority also might be, you know, to increase this group, because to belong to a group of people that want to do science, they're passionate about science, this is a great feeling for the person, a woman or whatever other human being to grow. So it's very important not to feel isolated.
Yeah, I really agreed, and I think every participant here is agreed with you, and that's why we are asking about the collaboration. That's why we're asking about, and we're talking about that we need to understand each other difficulties and opportunities, and that's why when one thing I want to share with you, when I was choosing, and the mathematics department was choosing the topic that we are going to have a seminar, and then we just decided that we should go for the opportunities, we could go for the challenges and the innovations, because we need it. Everybody can get the knowledge from the books and even to Google it, but now the need is to collaborate these ideas, and this is I feel that is a high demand of time. And here is Miss Humera, and she is from Hungary. And if Humera, you are having 2 minutes to tell us that how is the Hungary, and how the mathematicians are Hungary, and how the women in sciences can do in Hungary, and how we can get the good opportunities in Hungary. So these all questions are for you, and you are having 2 minutes only.
Assalamu alaikum, everyone. I am Humera, and thank you very much for giving me the opportunity to attend this webinar, and it really feels so honor for me to participate in this positive environment here. I am here from last year in September, and I am a PhD student in Budapest University of Technology and Economics, and my major is in graph theory. And nowadays I am working on characterizing minimally tough graph classes. And the environment here is very good. And the most of the people, especially for girls, they think that in Hungary there is no Pakistani community or whatever. But no, there are many students and lots of student communities here instead of the Jobians. And in every year on Stipendium Hungary Come Scholarship, 200 students come from Pakistan here. And the scholarship is offered in second week of November in every year. I'm also a Stipendium Hungary Come student here. And it is the HEC based scholarship basically, and every year 200 students are selected, 125 for bachelor's, 50 for master's program, and 25 for PhD programs for any subject. And it's very good opportunity for everyone.
And these are the right answers we need from you, and we are looking forward to you, Ms. Humera, to forward our students. We are not only looking forward to you, but we will forward our students to you for the good stipend and for the good opportunities in the sciences and mathematics particularly. And we will also send our students to Ms. Stefnila, Ms. Fatima, Dr. Fiza Zafar, Ms. Fujiha, and to Mr. Hadi, who is with us, but he is maybe scared with lot of women. He's the only man among these all women, I feel. I'm very thankful to you, and I'm very excited, and I'm very pleased that you make it a success story. And it can I or the Women University or the Department of Mathematics Women University can't do it without your this encouragement and this help and this positivity. And I am really very thankful, and thank you.
And at the end, thank you, Zil, for giving me that opportunity. And I am very excited that after a long time, I saw my teachers here, like my Dr. Fiza, my inspiration.
She is also mine.
Yes, Dr. Usman, Dr. Saima, and lots of people. After a long time, I see. And
so stay in contact with me, with us. We need your Hungarian stipend, actually.
Okay.
Yeah,
Yes,
this is
sure,
I'm
sure.
kidding, but yeah, we welcome everybody, especially from the renowned universities, and we are looking forward to have the collaboration. And so I feel that today was a beautiful session, and we spent a very beautiful day with each other.
Yes,
And
obviously.
the last comments, if you can do on, otherwise we can take lunch at last.
Yes, it's a very good learning experience for me too.
Yeah,
Yes.
please, Dr. Fiza Zafar and Mr. Wajia, Dr. Yes, please. Yes, Dr. Fiza Zafar.
Thank you, Zilishant, and you are all always welcome. I have also posted one of the group that I created in the capacity of vocal person for being women at STEM, along with one of my colleague, Dr. Suraya Manzoor, and we time to time share national international opportunities for professional development, also the fellowships, the short-term opportunities there, and we always also welcome the women in STEM of Pakistan. They can contact us anytime for the consultation if they want any guidance regarding applying for the higher opportunities, or they want any kind of guidance in the teaching, practicing out the teaching, the right teaching opportunities. And in fact, I have one of my PhD fellow, Dr. Tahira, is the master trainer in Punjab, and she's also being now attached with the National Curriculum Development and Primary and Secondary level. So I'm constantly in touch with her, and I'm thinking of also linking up, there was Hafsa who was telling us that she has difficulty in teaching in the school level. So we can link together, and I agree with Dr. Stephania and Dr. Fatima that together we can grow. There is no one individually can grow and excel. It's out of question. Thank you so much, all, and
Thank you
it's a
so much.
pleasure listening to everyone. You wonderful ladies, and congratulations on such a successful event. Thank you so much.
Thank you so much. And it is a success story of everybody who is participating in science and who is participating for the welfare of human being. And congratulations to all of you. And thank you so much for your precious time, and best of luck. And we are looking forward to have another gathering at any place. Either it can be hosted by Miss Dr. Fiza or Miss Stephnila or Dr.
Inshallah,
Miss
inshallah.
Humaira. And we are looking forward to meet
Surely.
each another again. Thank you so much, and good luck. Goodbye.
Good luck.
Good luck.
Bye. Bye, everyone.
Bye.
Goodbye.
Thank
Allah
you.
Hafiz.
Thank you.
Bye.
Thank you so much.
Bye.
Thank you.
Bye-bye.